All right, hello and welcome back to the GameDev show here with Andrew, Yorai, and Jason, and of course myself, Jason too. So welcome everybody. Happy Easter. We've got a lot to talk about, including Unreal, some cool stuff that Andrew's got on sale that I think maybe I'll start with. And I think we had quite a few other interesting topics. So just want to say hello to everybody in chat and give everybody a chance to say hi if you're out there.
Hello, everyone.
Hi-oh. Jason, welcome back.
Thanks.
I love that. Oh, hold on a second. Got to fix the rooms so you guys are at least like in the same room looking at each other.
Yeah,
I love it. By the way, I have an update on the battlers. I was going to tell you guys. I want to get Andrew's new low poly monsters in there, which will be coming very soon. But yesterday and the day before, in a little bit of spare time, I was able to get in some new characters. So I took the did you see the low poly characters that looked like the cute monster series pack that was on sale on the asset store? I took that and I put it in and I made the characters upgrade. So as you win, you level up to the next tier. And then I made it so that your stats actually level up with it too. So it just multiplies on those characters. It's going to be crazy, I'm sure. But I made it so that the code, or not the code, but the data is available in a link down below. You can go to game.courses/battlers or click the link. You can grab the scriptable objects, look at the stats, see what they are, and then make your choice for the battler. Or you can just pick it wild or take somebody else's suggestion. But we'll do that near the end of the show, but I just wanted to share it because I had fun doing it. And Andrew's low poly monster bundle kind of reminded me of that. So I think I'll share that bundle first. Just really briefly talk about the big sale that's going on, then we dive into some Unreal 5 stuff that works for you guys. Yep. So this is the character pack that you've got on sale today, Andrew?
Yep, it's the low poly monster bundle, 20 characters. It's only $30 on the spring sale flash deals. So there's 300 left, 294 left. So there's
at $1.50 a character. That seems pretty cheap.
I'm glad you could finally afford it, Jason. So now we can add it to the.
Now I can buy now. As soon as I stop screen sharing, I can buy now. I was gonna do it here, and then I realized that it's gonna put all my info up on the screen the second I do.
Yeah, you don't need to buy it. It's the stuff's already in the project, so.
Fair enough. It's already there.
Buy it, but you don't need to. You can save one copy for somebody else. Hopefully, it'll sell out. Who knows if it's going to sell out? We'll see.
Hopefully.
But yeah, this is now the complete bundle. There won't be more characters added to this one. 20 is the max. We're working on a bundle number 2. I mentioned that last week. Probably we'll launch that once there's 6 characters finished, which should happen, I don't know, in another couple weeks. Maybe a few weeks because I'm going to be gone for a week to a different country for work. So that'll be a downtime from. Oh, thank you, Rob. You're my new favorite person today.
Rob just mentioned in chat that he just grabbed the pack that Andrew has on sale. Yeah. You have one more sale pack coming up too, right?
Yeah, one of the monster bundles is coming up in a few days, I think 3 days. And then near the very end of the sale, the demons or devils by themselves will be on flash deal as well. So, I mean, the monster bundle is 50% off already for the one with the devils. So, if you really want the devils and the others, then it's probably better just to get the bundle for 50% off. But if you just want the devils, then you can wait for the near the end of the sale.
80%.
Yeah.
Nice. Okay. So then these ones are going to be 80% off as well, right? The 4 characters. Nice. Yeah. With all the blend shapes and stuff.
Yes, all the blend shapes, all the a lot of them, the earlier stuff will have music as well. A lot of them have sound effects. A lot of them have random particles that are ready to go. There might not be the best particles because I made them, so but they're there and they're easily replaceable with other textures if you'd like to. So there's a lot of bells and whistles to these that wardrobe is modular whenever possible. So pretty much all the time, whenever there's wardrobe, that is. So a lot going on. I know we've talked about a lot in these streams before. So for anyone who's new, just remember there's a lot going on. For everybody else, it's just a reminder that there's a lot going on here. It's not hard to use. I think that's a one of the feedback I get from customers sometimes is, variations of I'm new or I'm going to be on mobile, so these are going to be not good for mobile or hard to use. It's untrue. They've got, not much more poly count than Cinti Studio stuff does. They just have textures that look high fidelity, which you can make as small as you want. They don't have to be 4K. In your build, I think you would expect probably 1K or less, depending on your screen size. If it's mobile, 512 even. But yeah, so easy to use, fun to use, and modular. So.
And I'm not gonna lie, Andrew puts more effort into his custom inspectors than I do, and I put a lot of effort into my custom inspectors. So I legitimately, they're some of my favorite on the asset store. Like this is, I'm not the kind of person who's going to just say to one person that I know is stuff's better or not. It truthfully, a lot of asset store stuff is ass. Just is. There's a lot of bad stuff out there, and two things that I appreciate from the way Andrew does it. And again, I've told there's stuff I don't like that he does, and I've told him directly, so he knows that. But two things I do that honestly, compared to other asset store devs, I really do enjoy is one, the editors are designed with usability in mind. There's literally tooltips that are not just the standard hover over tooltips, but like full information where realistically there's a lot of complex sliders. And the second part that I really enjoy is that opening video on that asset store link is not just the normal introductory thing that's really well edited. It's this like sample project that demonstrates the kinds of things you'd want to do with it, and custom trailers and ads and stuff. Sorry, on the low poly one. That one is one of my favorite examples of like how you market an asset, because it shows you something practical, it's well edited, and it's a fun video. So that to me kind of highlights the care and attention put into assets, which I would like when I'm buying things.
Oh,
Yeah,
good.
and just to vouch to the fact that earlier you said there's a lot going on here, but it's actually quite simple. It's probably best to talk about why is there a lot going on here and what that a lot is. And a lot of things that people do, kind of forsake or don't think about when they buy an asset is that they just see the version that is in the screenshots, and they decide based on that. And that usually doesn't come with all the customization options and the effort that you have to take in order to even have the content be customizable in the first place to have all that. Getting all the palette swaps while keeping all the detail isn't trivial. Getting all the blend shapes is not trivial at all if you have any complex rigging whatsoever. It's just it's a list that cascades in the amount of complexity if you had to try and do it all by yourself. And this just comes with all of it out of the box with components for easy usability in mind. So, I mean, I'm vouching for it. It's good.
Hashtag not sponsored.
Yeah, not sponsored at all. Completely serious. Yeah.
So hopefully people who do like the stuff and buy it will be very pleased with the result, and with what you can do with it. What hopefully will enable new ideas for your games, new mechanics, new things, whether it be just bad guys that all look slightly different from each other or customizable players.
Yeah, what do you think people do more often? Do they just randomize enemies, or do they like actually implement the character customization and allow people to do it? Do you know?
Well, with the humans, I think more are doing the customization of the humans. I know there's a RVR is another YouTuber who has a Souls tutorial series right now, and he's using the humans, the troll, the goblin in that series. I'll find the link and we can link out to it because it's a really well done tutorial series, and he's using them, and in that he's got the customization going on. So there's that. I know more people are doing that. I've got a customization sample scene. There you go.
This the guy?
Yeah, that's the one. So the souls like if you click on videos, you'll probably find the latest ones and go from there. There you go. Those ones. He has a little sizzle reel at the beginning. I think that'll show a little bit more of it. A lot of it, the videos are just coding and setup and whatnot. But yeah. So with the demo scene, a demo character creation scene that I've got, it makes it a little bit easier to kind of get your head around how you would go about customizing it. It's not complicated once you understand it, but I've got an editor tool, an inspector that basically lets you set up characters and the way sliders and pre-made, predetermined settings of wardrobe and stuff. So you can switch from a full armor outfit to, more leather armor to regular clothes just with one line of code once you set it up in the inspector. And setting up in the inspector is kind of just clicking buttons, dragging things, and typing in the names of things, and then going from there. So it's not terribly complicated, except that there's just a lot going on because you now are thinking, oh, I've got humans, half orcs, elves, male, female, different skin tones, hair colors, hair types, and how do I do this? And once you set it up, it's just click, 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 one line of code, and it just works, which is, that's the magical part where things just work.
And, even on the simpler level, there's a lot of things that people don't think about and take for granted. But if you have all these meshes that are stacked on top of each other, and each of them has to support blend shapes, you'd have to go for each mesh and drag the blend shapes individually, usually. But your components have a slider that does that for all the submeshes at once, which was like a really nice time saver to see how something looks given a customization option.
Yeah, so basically the details of that are, the body will have, let's say, arm muscle, make it bigger. So arm muscle plus, arm muscle minus. My script will put that into one slider, slide left and right, make the arm muscle bigger, smaller. But now if you've got armor on that, the armor needs to go bigger, smaller too. So we add a shape to the armor that has a similar name, slightly different, but the script, recognizing the naming convention, will now match that shape every time the arm happens. So, and basically it all happens behind the scenes. So when you equip the armor using this equip script, which is one line of code, it also relinks all the blend shapes together. So now if the arm is already big, it will equip the armor, turn it on, and change the blend shape bigger. So now it matches. And now when you move that slider, the armor on top of it also moves. And, 98% accuracy, I would say. When you start adding a ton of them, it can get a little wonky, but it's to the point where most of the time you'll never notice any clipping or anything like that. And we try and minimize that when we notice it. And so it's a naming convention thing. That's all it is. And I wish other publishers would utilize it. I've offered to, people to use the script, and you can change the naming as well. You don't have to use my naming convention as long as you have a naming convention, but nobody else has done it yet. I think because it does take, it doubles or more that the setup time actually, it's you rig a character, you animate it, and you're done, or you rig it, animate it, and now you build all these blend shapes, which takes a lot more time and effort and whatnot.
This actually reminds me, Jason, on your model that you sent a few weeks back, where the bones were rejected by Mixamo, I ended up making a Python script that in like 1 minute changed all the bone names to the ones that Mixamo uses. For the mesh itself plus all the for the rig itself plus all the meshes on it. That was really nice, like just setting up a simple table and saying this is the original bone name, this is the intended bone name, just click convert, and it converted everything.
Nice.
Yeah, so it's like a 3-minute setup now on my end to fix stuff like that.
That seems really handy. You should turn that into a Unity extension.
It's a Blender thing, but Python.
You should just send me that Python script so I can use it.
It was included in the file I sent you.
All the time.
It's in the file I sent you.
And then I missed it. I'm gonna have to dig back through there and take a look. I got that character up and running around and stuff too. I got some stuff to share with that. It'd be really cool. It's fun. And some blend shape shit. Andrew got me going on that, so I got to share that soon. Go ahead, Jason.
And I was gonna say, I think it's worth pointing out as well why Andrew stuff has all of this like extra details and sort of helper tools, is because there's a general problem with a lot of asset development stuff where things are built to be assets. And I think if you're following along with Andrew's channel, he's like making game stuff. So there's the concept of dog fooding we've talked about before. And I think that to me is the like #1 gold star difference. There's a lot of projects and assets out there which are built to look good in a video, a trailer, or an example and sell. Andrew's going the other way, where he's making a thing for himself and then going, what would be the steps required to turn this into an asset, which is just modifying it to make it more user-friendly for someone who's not familiar with how it works. And you can tell, because a lot of the slider stuff may seem like you wouldn't think about it unless you're doing it. That's one of the biggest issues with something like this, where when if you make a character for your game, there's like so many things that'll come up over time. Like you won't think about the armor and stuff at first. You'll just say make a character. Then later on you might want armor. Later on you might want whatever, and you'll end up having to retrofit things to make new things work. But because they're all being kind of stacked for the actual purposes of solving a problem, which is making characters in a customization, you can kind of see that, right? That it's like building in the structure of something that's actually solving problems. And I think that's you can start to spot these, that there's certain kinds of videos on the asset store now which are too polished visually that kind of bother me, because I've bought a few assets where they look really nice, but it's like one camera angle with a nice timeline, animated cinemachine, and you're like, show me the other side of that. Is there actually anything else, or is this just a really well placed 5 rocks in a tree? And so I'm always appreciative when I see something that looks worked on.
Yeah, it actually reminds me that the time Stylized Water 2 got released on release day. I got it and I was like all excited to try it out. And I literally opened the scene, disabled the directional light, and I wanted to see how a single spotlight in the dark on the water looks like. And it didn't. The entire thing didn't even support spotlights properly for what I had at the time. Like it was a super simple scene, but there was like something that's going amiss there, and I just had to send and ask, and he said he didn't even try it because the trailer goal scene thing was using just a directional light. It's a fantastic asset. Just wanted to point it out. It was just the beginning phase, like corrected quickly. It's funny.
So are you guys ready to start talking about a little Unreal? I know it was a big topic last week we didn't get into, and I think it's a big topic that most people are interested in. So we may as well just dive right into it. I don't know how much you guys have been watching and keeping up with it. I've been kind of loosely going through videos and trying to get a good idea of what's going on and get used to it. But let's pull up these notes instead. I'm curious what your guys' initial impressions and initial thoughts were of the Unreal 5 release and announcement. Sorry, my restream is lagging out for some reason. There we go.
There we go. So my initial impression of Unreal 5 is mouth-wateringly, I want to play with it, but I have other things I had to do, so I didn't get the chance to yet. I already tried it out when the beta came out, when they just announced it and became available prior to release, and that was a really fun short experiment. But now, seeing the full changelog, there are way more interesting things and unsung heroes here than I thought there would be, and I'm excited.
Nice. Yeah, there's definitely a lot of cool stuff in there. What about you, Jason? Did you?
Yeah, I mean, it's hard to deny they're going sort of strength to strength, right? Like for me, what interests me the most is just it's always looked good in Unreal, but the problem has been practicality, where like you can have the prettiest thing in the world, but if you're going to be dropping like high-res models and things into an engine, you're going to quickly get into issues. The things that inspire me the most with what Unreal are doing, again, it come back to this idea of earlier about dogfooding, is they're taking away steps of complexity for people who don't need to know all of the gritty details. The more and more of these features are kind of performance by default style approaches, right? Like you can have models which are sub-optimized or kind of unoptimized and have them magically seem to work using a combination of various different features that would change how they render. And so what interests me is the fact that it allows you to play around more. The biggest issue I have with game engines as a whole is you end up with two extremes. You end up with the game makers and the Godots, which are really, really great to just like put something in and get an example going within 20 minutes. And then you have the Unities in Unreal, which is like sit down for 4 hours to get your first cube rendering, and then you can start doing whatever it is you actually intend to start doing. And so having more engines focus on taking out some of the stress of just like setting it up correctly is what inspires me most. And so, yeah, I'm quite impressed with a lot of the things they're doing, the kind of like, obviously you've got amazing lighting and amazing rendering, but it's kind of the actory stuff that's more interesting to me and how they're handling just generally making projects from a starting point. So I may be diving back in. I haven't used I briefly used it using UE4 when it first came out as a test, but I hadn't actually done a project in an Unreal thing since UDK back in the day. So that was quite a while ago. So I'll be curious to kind of see how I feel about it now. But yeah, we'll see.
Nice. So yeah, I was kind of the same. So this is the difference. It's interesting seeing the lighting difference. He's gonna just briefly talk about what the like the most exciting systems are, because I think there's a lot of shit that I thought was cool. I mean, Nanite and Lumen were the most exciting things, and I think this is
Nanite especially is insane. Like it's legitimately like mind blowing.
That's the one that like I just wish like that was in Unity already, or it could be, because it's really really cool. So should we just talk about Nanite first?
Yeah,
Talk about what it is and briefly how it works. Let me see if I can find like a nice video that explains it too, that shows it. But it essentially is like a live LOD system that's automatic and super high detail. Like it seems, from at least every video I've watched so far, seems like you can just take in super HD multi-million poly models, drop them in, and then it will auto LOD them live for you and make it work. So you can drop in whatever you want and have it just perform for the most part, except for obviously there's some specific types of rendering that it didn't work with. But for 99% of things, it seemed like you just check a box and you get a huge performance improvement just from automatic, essentially like a really intelligent new automatic LOD system. That sound about right?
It's close to say that. There are some limitations with it, but generally speaking, the concept of having performant rendering for a high detailed model has been a nightmare to work out, because you can't just alpha a model once, use it, and expect it to work perfectly for even the low end machines. And Nanite, what it does is literally give you that. You offer the model once, you drop it in, and you never have to care about it again, because it does all the hard work for you, and it even generates the low load stuff automatically to be used if you are shipping to a low end platform.
Yeah, it seems insane, right? It seems like exactly what I've always wished you could do. So I hope that we get something similar to this. Let's see, is there a video that shows the part that shows it?
The thing that is most insane about it is they managed to make some level of subsurface or quote or related close to animation going with it, which was like supposed to be really really difficult. Initially, when it dropped in the Unreal 5 beta, it only worked for meshes that had no any sort of animation to them, mainly because the way it worked didn't particularly allow it. So you couldn't say make a super high poly character with clothes, but you could make a super high poly rock, desert, statues, and other intricate level stuff. And they even back then they still supported the idea of those big static objects being slapped on animated characters. So there was this gigantic titan with really intricate details, and it used Nanite to look super fancy. And it worked because it was a mechanical looking enemy. So the bone moves were rigid, but you can't use it for deformed characters, as far as I understand right now. It might have changed slightly since. I didn't see anything that would indicate that, though.
Yeah, I know there were some restrictions that I saw, like things like hair and transparency and stuff, but I didn't see that. I didn't go too deep into it. I really want to play with it, though. I'm just impressed by how automagic it is. Like,
yeah, I really want to limit test it. Yeah, it was like, I'm really not sure how they're doing some parts of it, but I really want to dive deep into it and see like how far can you actually push this. Because just trying to have 4 different versions of a model in a project is already pain in the ass in Unity. Using the lot groups, trying to figure out like, you go from this distance to that distance, and how do I even generate it? And then you go into the topic of imposters and all that. And even just the matter of depth and overlapping Z's when you say you add two cubes in Unity and they partially overlap, you get this weird flickering if they have different colors. Do you ever get that? This doesn't happen when you use Nanite because the mesh has all the depth to have the Z-Wars result, and you don't get any of these power-ups. And it's even crazier that you can get that with Quixel, the asset library that they provide, and you get the high poly meshes, and you can drag them in, and they will not have any C issues whatsoever until you try and make the low-end project, which is supposed to generate the small meshes, which will lose the detail, and then you'll start seeing those issues. I didn't see how that solves out yet, but this is the kind of limit testing I'm talking about.
But it seemed like the meshes too get compressed nice and tiny. So yeah, even like the big high def meshes, it seemed like, at least from the one example that I remember, it seemed like they were really, really small. Like somehow they were compressing it down a shitload. So I don't know exactly what's going on there, but I just want something like this to come to Unity now. Like, it'd be nice if they just add an option in there, like 2023, we're going to have a checkbox to just auto LOD everything, or a rendering option in URP or HDRP to do it.
Yeah, that would be nice. So there are some comments that we should probably read, if that's
Sure.
okay.
Yeah.
So somebody is asking, how would Nanite work with destructible objects? Can the new destruction engine be applied on high-res static Nanite objects? Yeah, it should. So technically speaking, it should. But when you're fracturing something, you need to make a new mesh. So the fracture itself is probably going to be part of the problem here. Also, take in mind that really high-end meshes will consume memory. So it's not like it's free to have all of this. You pay a cost. It's just not the cost of offering. It's the cost in the computer specs needed. Performance is good. That's not the problem there. It's just it needs more resources to do its thing. You can't pool 6 million vertices and expect them to not take the memory that they take.
Somebody saying it didn't apply in the demo. I don't know if that's just because it was older though.
Yeah. So again, it was just a theory, but like if you pre-made Nanite destructible mesh, and it was, say it was a rigged object where, or rather not rigged, it was just a bunch of objects, and each of them was using Nanite, and you just spread them all out, it should work perfectly fine in theory. Obviously, the collision meshes would have to be way simpler, because that's a different topic from the rendering. Yeah.
You just turn it on for all the stuff that it works for, and turn it off for the few things that it doesn't. Still good.
Well, that's it, right? Like, it is worth keeping an eye on what we're talking about here. Like, it's about problem solving, and the biggest issue is that things in the distance tend to be low resolution because they kind of have to be, because they're either big and always being visible by the camera and cost a lot, or you just want to avoid issues with kind of large objects in general. So yes, it may not apply to everything, but like not every solution is a catch-all for every problem. But the idea of having a large, high resolution, detailed environment is one problem, and this is a solved problem now. And kind of that's the point, right? If even if it's exclusively just used for the environment, that's already a huge win, because that's going to represent the most amount of visual triangles on your screen at any given time. All of the floors, all of the walls, all of the rocks in the background, and it means you're not going to get that, like, whether or not it's something that comes up a lot. The markers for quality in a lot of people's minds are easy to detect. One of them just being pop-in. Anyone who's ever played a video game, we know what that looks like, and there's that instant eye twitch of, oh, okay, the magic is lost. It takes me out of whatever I'm doing. I've seen a flaw. So, like, having large items in the background, be able to smoothly transition in ways that have high resolution, like I said, that alone is enough for me. I don't need it to also sing and dance at the same time, you know.
So some people are saying that we're wrong regarding Nanite and it not being a LODS system. So let's just dive into the technicalities a bit, because we're discussing the concept of levels of detail, not the actual implementation that levels of detail used in games up to this point in time. There's a big
Yeah,
difference.
keep in mind that the phrase level of detail is true. The level of the detail is in fact changing as you move around. Yes, it may not be a LOD system, but it's worth keeping in mind. There's a lot of
So
language
sorry about the
differences.
misunderstanding here. We were discussing the concept of level of detail, and if we just want to read out loud the Nanite virtualized geometry, just so everybody's on the same page and nobody's having any issues here. Nanite's visualized micropolygon geometry system enables developers to create games with massive amounts of geometric detail. You can directly import film quality source art composed of millions of polygons, anything from ZBrush to sculpts to photogrammetry scans, and place them millions of times, all while maintaining real-time frame rate and without any noticeable loss of fidelity. But there is a loss of fidelity, it's just not noticeable. And Nanite intelligently streams and processes only details you can perceive, largely removing triangle count and draw call constraints. It eliminates time-consuming work, such as baking details to normal maps and manually offering levels of detail, freeing you from to concentrate on creativity. So it's literally right there, from manually offering levels of detail.
I think the promise of it is amazing, of course, and that's what gets everyone so excited. The idea that you can take some high resolution scanner model and not worry about the rest. I mean, it's the magic button aspect here. To your point, Uri, how it actually plays out in the wild remains to be seen. There's probably caveats left and right about what the mesh needs to look like. Will it work with like a faceted look? Probably not, I would imagine. What at what point does it become like, okay, to use this you really have to have a scan and all this like high res models that might be harder for regular indie developers to find without using Quixel? And maybe if you're using Unreal, then of course use Quixel. But there's probably a lot of caveats here which remain to be seen, but the promise is really nice. The idea that you can just throw it in there and it's going to work because it's not rocket science, although I hear rocket science isn't that difficult, because so maybe it's rocket
easier now.
It's rocket science where there's an A, B, C, and you go from A to C. The magic is that it just happens for you and you don't have to do it manually.
Yeah, it's also worth noting like the confluence of technologies here, because there's a lot of stuff which is still in the realm of theoreticals, as in it's doable, but it's not doable to the level that's realistic. Two things that fall into this has generally been using 3D scan models in games, and the second has been all of the raycast lighting stuff in general. These are both really powerful technologies, which we're still on the cusp of balancing between how much resources a computer has versus the practicality of using it in the game and making it work in a way that's not going to be like a showpiece. Same with like games like Tomb Raider, which have the magic hair button you can press, which makes everything fancier. Like these things to me are still, they're showpieces. They're not practically, because they take up so much resources relative to the effect they give you. It's a trade-off. And I guess my point is, why this is valuable is not just the fact that it's high resolution models. It's that the authoring process of I want a nice rock face in my game usually is you go take some sample images, you have an artist 3D model it, you make this big 3D model thing, you then make your LODs or whatever, you bring it into your engine, you author it, you tweak it, and you work in this cycle of development time. The other end of the spectrum is people going, well, why not just use 3D scans? 3D scans are extremely unoptimized, and there's a process that you don't think about that goes from, I've taken a real world model, how do I actually use this in a game? Because it's laughably impractical to take it's just a scan you would use for a high-res render and actually put it into a live real-time game kind of environment. And the reason this is important is because it bridges that gap. It says not only is it easier to render high-resolution things, but it's the fact that it's building a pipeline from this previously only really useful for renders to this is usable in games. And it's these kinds of kind of confluence of technologies which are leading to the interesting parts for me, because it's where you take things for different purposes that were only really used, as experiments, and putting them in practically. Like again, ray tracing demos are not as new as people think they are. They have been ray tracing demos for years, but they've been like a spinning circle in a demo in some showroom somewhere because it was previously laughable to even try to render more than 2 things with all of the various different lighting
It's a
effects.
nice donut going around.
Yeah, and so like it's not like the technology's not been there. It's the practicality of making it efficient and being able to scale it up and being able to deliver it in a way that's applicable to the average game developer who doesn't need a unique in-house person who knows that technology and can exclusively implement it. And that's where we're getting at. You can now have an artist who's not going to go out and like manually do their own 3D scans and then manually like fix the model so that it's not too crazy with the topology. And now it's just like, how about we just buy one that's a really high res model and pop it into our game and it works, right? So again, it's not just the fact that it's good rendering, it's the fact that it's simplifying a pipeline that allows you to go from ideation to practicality in a much, much thinner kind of timeline.
So just touching on some of the comments going on. So first off, the one regarding upping the memory costs, because it's streaming from SSD shouldn't raise memory costs. Yeah, this comment. True, but now you're relying on having SSDs that have proper speed of doing all of that process, which
Do you
is
guys
not to be
feel like
taken for
that's
granted.
something you can count on now, having relatively fast disk
No,
access?
I think
No.
that's a misnomer because I think what a lot of people make the mistake of is there's this now, oh, you have an SSD? Well, you've got high performance read write now. It's like, well, no, actually, SSDs are not all built the same. On top of that, there's like, not only is there the different kinds of SSDs, but on top of that, certain SSDs are cheating. There's hybrids. And if you don't know what you're doing or you don't know which ones you have, the scratch disk memory, in other words, if your SSD is too full, it will not give you the effect you'll expect. And there's a lot of other like nuances in how an SSD reads and writes that even if you are doing the right thing and buying the right hard drive, if you've got too much stuff on the hard drive, it's not going to read right. Or sometimes people simply don't know the difference and they'll default install to a different hard drive. And they don't realize that, yeah, you could install onto your bigger, your normal disk drive because it's a larger space for all of your Steam library, but then you're not getting the benefits of your read write stuff. There's a reason why, like, there's a kind of running joke between the whole console and PC stuff and PC master race and all that, but there is something to be said that if you work for a dedicated piece of hardware, you can really eke out things that you can't do on a PC where all of the specs are different. The classic example was Android development in terms of device screen sizes. Anybody who's ever had to develop anything for Android knows it's a nightmare when you know that the device can have anything from like a 4-inch screen to a tablet, a giant size. So you have to completely reauthor everything to match those specs. And with a console developer knows what memory, where. They literally have every single piece of information they need that's mostly replicatable. And so a lot of the fancy read-write stuff that's happening on PS5 is not quite applicable yet to PCs. The technology may be, but like until you have a reliable user base that has high-end equipment, that's not going to work. That's what Steam tried to address with Steam boxes and stuff. When they tried to build machines, people thought it was just them building cheap computers, but it wasn't. The real selling point of if that had worked, if Valve had succeeded in getting people to buy into their ecosystem, is they would have had a console-style ecosystem. They would have had a baseline developers could understand, and unless stuff was swapped out, they could have reliable hardware. If you have reliable hardware, you can do kind of hacks that specifically target the hardware that's far more efficient. And yeah, so it's not likely to happen on PC in the same way. That's not saying there isn't some benefits, but like you can't equate the SSD read-write magic that could happen on a console to stuff that'll happen on PC, because no two people will have the same SSD, and the SSDs targeting consumer grade are different. They have a different purpose. They're predominantly used for people will store stuff, and they don't have the same constant read-write access that you're going to have on a console, which is like constantly cycling.
Yeah,
What
perfectly
do you
spoken.
feel about like mobile disk access speed? Has that like influenced things or sped things up? Because it's got to be faster than old hard drives, right? Because you're going straight to flash memory. So like, do you feel like that's kind of like the new baseline is as long as it's fast enough to run on or stream on mobile that it's good? Or like where do you think the limit is? Like I guess like what would be your bottom spec for targeting a hard drives or systems there if you were trying to do streaming from devices? Because I think back to like I've had old IDE devices or shitty old SATA drives that were really slow, and then they doubled and doubled and doubled the speeds. Like where's kind of like what would you guys think is like a cutoff? Or I mean, I guess it probably depends per game.
Yeah, so yeah, actually, to get back into that, there were some other comments I wanted to address before the fantastically spoken SSD rant came up. Thank you, Jason, again.
Yeah, sorry about that. It's just
yeah.
SSDs.
Yeah,
Like I say this as somebody who like I love this phrase that says the first step to knowing something is not knowing it. And I was this guy. I bought an SSD with the intention of upgrading my machine, and I was having a chat in a mastermind group at one stage with a bunch of people, and they're like, "Oh, which one do you get?" It's like just reread, just double check the specs on that. And then I decided, I realized I haven't looked into the difference. I bought into the I used to have hard drives. I went straight over to SSDs. I'm like, SSDs are great. I there are big companies like Samsung. I'll buy the nice fancy one, and I don't know what I'm doing. And it's not until you go in, you start reading about the differences between NVMe and like the way it works and which ones are useful. I think Linus Tech Tips has like 2 videos that explains this in detail in terms of how hybrid drives work, especially. But yeah, like it's easy to be tricked because there's a lot of language that will kind of allude to like it is faster, but it's the way it's faster is different and how it works is different. And so it is worth keeping an eye on this stuff because like it's not intuitive is I guess the point.
So I wasn't the only one wondering this question. Before Yorai jumps over to it, we'll wrap up SSDs with the recommendation. So you did do the research and all that. Now, what's the recommended SSD from Jason?
So
oh God, I'm not going to give a recommendation. That's too dangerous.
Or what did you end up with?
Let's just give some terminology instead. So you had HDD, which of course hard drives, and they were the default speed that we ran for eons. Then they also had tiers in them for the
but if we're going to go down that, it's worth noting how they work too, right? It's worth saying if you're measuring hard drives and how they worked, they were measured by RPM, right? They were measured literally by there's a needle point on the disk, and you're reading information, and the read speed is literally how much can I spin this and realistically still get the data. So when you looked at hard drives, you're rating it by how fast can I spin it to capture the information on it, and that's why the idea of moving from that to a solid state drive is not just about speed; it's also a massive leap because it means if you jostle the disk is spinning. If it jostles a little bit, you can actually destroy the disk, and that's why moving a network storage or something can actually destroy it entirely if you mess with it incorrectly. So yeah, there's going from spinning disks is a big change.
That's worth hard memory, yeah.
So then we move to solid state drives, which Jason just explained. Different technology, different outcomes. Generally speaking, people will always mention some big figure like it's 5 times faster than HDD. And then we had
that fast though, because even with like old SATA SSDs, they could have been faster at seeks, but not so much at throughput. Like actual reading large files wasn't that much faster because you'd get capped out by that SATA bus at 300 megabytes or 600 megabytes a second. So they would find things like small files faster, but big stuff, they weren't that much faster initially until this new change that I assume you're going to jump into.
And it is worth noting as well that the purposes are different, right? Hard drives could, depending on your use case, there are different hard drives that are better for long-term storage versus ones that are better for read-writes. So that's just as an aside as we go down to this. When you're buying a hard drive, like you will buy different RAID hard drives, for example, than the kinds of hard drives you would buy for your normal like operating system.
Yeah. So going into the comment that's displaying right now from Preferred Virus. Solid state drives had a fuller name that was SATA SSD. And these days we have NVMe SSD, which is another step up in the direction of how fast the drives go. And we're talking about, I think it's around the 4 gigabytes per second these days compared to the 600 megabytes or so it used to be, something like that. Yeah. So it's again a giant leap, almost a magnitude or an order of magnitude higher in terms of reading. And if we're going back to HDD, from that, we're seeing 100 times speed difference. So when you're loading those large assets with Nanite, you're asking, can I do this fast enough? If somebody is using an NVMe, which most recent tech high-end PCs or I think PS5 has an NVMe use, then yeah, sure, you'll load at 100 times speed a big asset instantly to get the look that Nanite wants to give you. But if you're on an HDD, God help you with that. So it's not free. Now,
It depends on
that
the
also-
size, though. It still
Yeah.
might be small
Yeah.
enough that it'll
And a
fine.
comment that I've been holding out on since before the SSD rant is that it's not just the reading speed, is that you still don't have free reign on the asset size. Because if you want a gigantic mesh right now and you put absolutely no effort into optimizing it, you will still slow down how your game loads, but more importantly, the download sizes and the space consumption, which are valid complaints in the gaming communities. We have games that are 200 gigabytes big. It's not easy to download. It's not easy to update, especially for people with bad net connections. It's not something that you can take for granted. Just Nanite is scaling up costs in certain places, just not places that you tend to care about when the game actually runs.
Or when you're a developer, right? Like, it's simplifying the developer's job. Make it a little harder.
Yeah, so just to touch on that, because it's actually a fantastic point, Nanite can actually create simplified meshes for you, if I recall. Or there's at least one system in Unreal 5 that does that for you. They specifically mentioned it somewhere. And that can turn down the build size, regardless of how fancy you're working in your dev environment. So there is a big difference if you're a developer or a consumer. But you should care about how the consumer ends up with whatever files they have. Nothing is free, even with new tech. Also, to those who say that you should probably enable Nanite even on low-end projects, you should. You should definitely do that. It's just fantastic tech.
Recommended on everything.
Yeah, it's regardless of if you're using high-end models or not. With high-end models, you're going to get more benefits, but there are some small caveats. I think somebody mentioned it in the comments earlier, but something about you can't use displacement or tessellation from the texture when you're using Nanite. I don't know if it's actually correct, because I think you can still change the
That's
Nanite
what
shaders.
I heard last. The last thing I saw said that.
So I'm not 100% sure on that, but I just wanted to highlight that comment from earlier. I think it was from Daniel Zanotti, or
I want to hit two things real quick. If you don't, just this thing, the comment that I have up here, because I think it's an important one, and maybe this is what hit you, Jason, is that the M2 drives, the ones that go on the motherboard, the solid state drives, they're not all NVMe.
Right? Yeah, they're not. That reminds me of the HD ready nonsense back in the day, where it's this like really cheeky marketing crap, which makes you think that you're getting a good upgrade, but it's like, no, it's still SATA. You're just, that definitely can get you. Yeah.
Yeah, so that's what you want to watch out for. When you get it, make sure that it's NVMe, not SATA, even if it's the M2 ones. It happened to me. I bought one and I was like, oh, this one's cheaper. I didn't realize it was $30 cheaper because it was SATA. I'd been looking at drives for a while and didn't even know there were two different versions of it. And I think it was like a 970. I ended up with a 980 Pros. I don't know what you're using. Somebody's asking.
Evos? Yeah, same. I think I have the same actually at the moment.
980 Pro, yeah. I actually just upgraded to a 2 terabyte one because my 1 terabyte one keeps filling up from all these giant store assets. I grabbed all the stuff that was on sale and it's like constantly full, and then I record a video and it runs out of space and stops because I downloaded too many assets that morning. So
I do think it's worth, like, this is going to get a little bit, again, I'm always worried about the levels of which we're talking about certain topics. Just something, this is more of the philosophy of what we're talking about, because I think it's interesting to cover. Something that's, again, not super intuitive at first, and it took me a while to kind of get my head around, is it may sound obvious to say, but the fastest something can ever be is whatever the longest running thing is at the base level. In other words, your throughput is entirely limited by whatever takes the longest. If you've got a pipeline and one step takes 10 seconds or 10 milliseconds or whatever, you'll never get slower than the time it actually takes to do the thing. And so the cost is going to be the additions of what's happening. What I mean by this is there is even like millisecond latency on your monitor. You don't think about it, but there's so many steps. And this is going from like if you move your mouse, there's the motor functions of you deciding what to do, to your hand to the mouse to the computer to the operating system to the rendering to the drawing to the screen. And it's just a whole lot. Like there's each one of these things is small, but they add up. And similarly, the reason why we're harping on so much about hard drives is because for all of these rendering, people often divorce themselves from the fact that at the end of the day, if you're drawing a shape on screen, you have to get the shape. And so there is a pipeline that goes from where is it how do I load it? Which way am I loading it? Because the other thing too is depending on which way you're doing things, like there's a lot of abstraction levels in operating systems, and sometimes things are slow to load by going through the operating system and basically requesting access. It's like, imagine packaging something up, delivering it, opening the package and taking it out. If you could have a deal to arrange directly with the deliverer to deliver to you in a form factor you can use, suddenly things are faster. So a lot of these conversations are boiling down to, can we get more direct access to the memory itself rather than going through the request of the operating system or other channels of how things work? So that's kind of what we're talking about here, is that the more of this middleware we can get rid of, and the more we can directly access memory, and the more stuff we can hold in RAM, faster access rather than having to go back to the hard drive, is kind of where this is. And there's a lot of nuance to this discussion that's very kind of, it's above my pay grade, to be honest, but it's like there's a lot to look into. And so, yeah, hard drives is only one part of this process. And it's why it's not something that you can rely on when in consumer grade, most hard drives are bought with the presumption they're used for the average computer, and the average computer is watching Netflix and using Chrome and writing documents. And so there really is a targeted difference between the intentionality of a piece of hardware and what it's being used for. Consoles are built for doing the game thing. They're specifically for games, and so the decision making around what hardware to include is very different. So yeah, that's kind of the point here, is that we're not saying you can't get a lot of this stuff, but hard drives is one area where you do have to know what you're looking into, and it's worth, if you're buying a computer for gaming, keep that in mind and do your research. And same with everything else, same with RAM, and same with a bunch of other topics. Like you could buy faster processors than you actually, that would be faster for different purposes than the ones you have. Theoretically, you can buy things which have different thread counts and different solutions that will work faster for certain processes, but not for ones you expect, based on multi-threading and whatever. So
Like
this is just as a
64-core Threadripper.
yeah, right. Like
Play single-threaded games.
right. Like exactly. Like it's going to get to the point where it's just worth saying that there's a lot in this that's, yeah, you get my point. It's just that there's research to do if you're thinking about it from a game perspective, and it's not just a matter of buying something that's more expensive. You can actually hilariously get something that's underperforming if you buy all of the best equipment, because the purpose it's targeted for is vastly different, and you'll have all of this performance on the table that you're not using. So
You
yeah,
know, I can think of a good example of that I've seen happen in the past with friends who came into some money and then bought Quattro cards for their gaming, because those were the most expensive of the video cards, and they're confused why they're getting worse performance than the person with the $300 video card next to them. Because those are specialized for, for the job that they do. So at least they used to be. I know that they've actually gotten quite a bit faster. At least last time I looked, although I don't know if they still make them. They still make the Quattro cards, right? But they switched them
I
up to
assume so.
the new chipset so that they actually render fast for 3D games. I thought. I can't remember what they've done with them though. I never bought them myself, so.
Yeah, I mean, I'm not a general consumer of rendering grade equipment.
Yeah. So speaking of rendering, you guys want to jump over to Lumen?
Yeah.
Talk
sure.
a little bit about Unreal's new light system.
Yeah. One more comment before we jump into this, though. Somebody asked how Nanite would play with networking, and I just wanted to clarify: Nanite has nothing to do with networking. Sorry. If you are concerned about that, the thing that you're thinking of is probably, I'm seeing a fancy mesh and somebody's on the network. If they take loading times, what do I do when I wait for them, or something like that? That's an entirely separate concern. Or if you're concerned about collisions, physics, whatever have you, all of these systems are separate from Nanite. Nanite is only responsible for loading a fancy-looking thing, showing a fancy-looking thing. Everything else is separate systems. They haven't changed. They work just as fine with Unreal 4, Unreal 5. They will work as expected.
And it's worth noting.
Do you need normal maps?
What? You shouldn't need normal maps, because normal maps, what they do is, generally speaking, they compensate for the lack of geometry in the scene. So when you're using a high-end mesh, you don't need a normal map, because all of the detail, the normals that you'd have, are on the mesh. This is part of what's making everything faster for offering content now. You can just make a good-looking mesh that has all the details that you need, drop it in the hard drive, drop it into the project, and see it with all the lighting and whatever else Unreal 5 has.
Yeah, and actually, it might be worth pointing out what normal maps do /R, because I don't think that might be something new for people. So what you can do is, we kind of talked about it, everything's basically triangles. At the end of the day, it's all triangles. It's turtles all the way down, as they say. And every triangle costs, you have to physically draw it. And it's weird to think about it, but like a computer is just, it's like somebody going through a list of tasks, and their tasks have been draw a triangle here, a draw a triangle here, a draw a triangle here, and they're just going to go through and do it, and they're going to try to do it efficiently. And certain things would be like drawing one in front of another. They'll have to make decisions like, oh, you don't need to draw that, we'll draw this in front of it, and this kind of thing. So all that rendering is basically building a task list in a way that's trying to avoid doing unnecessary work, like drawing stuff that'll be occluded by other stuff. That's why overdraw is an issue, because if you draw one thing, you draw something transparent over it, you're going to see both. Like, there's a whole lot of stuff. But my point is, if that's all you're doing is drawing things, you can have really complex models which have an interesting shape. So say I have a rock which has like little barnacle. Actually, a good example is metal girders. That's a big common one. You've got a metal girder and it's got like nuts and bolts on the piece of metal. You can physically model a bunch of bolts, and each one of these has their own little geometry and their own little parts to it, and the amount of triangles in that are exponentially higher than having just a rectangle. Where if it's a rectangle with painted circles on the texture, there's no extra geometry. But if you have so much as one extra bolt on there, there's a lot of geometry on that particular set of triangles, which then modifies the entire shape of the geometry and makes the whole thing more complicated. So what you can do with, say, something like ZBrush is you can take something simple, like just a standard triangle, and then or rectangle, and then you can make this extra detailed stuff. You can like paint on all of these nuts and bolts and gouges and stuff into it. And then rather than actually export a model, the high resolution model, you can take that resulting thing and you could say, hey, all of these changes, bake it into a texture. Just show me where things are different. Things are out a bit, things are in a bit, basically. And then when you draw that, you can bring in your low resolution rectangle, apply a normal map, and a normal map says, hey, when you're about to draw this, rather than draw everything flush and flat, these things, push them out a bit or pull them in a bit relative to this amount of like displacement is what you call it. And that will give it the impression that it's like, oh, cool, this little bit here is out a bit more. So it physically has a shape where it wouldn't have had a shape because the actual model you're rendering is just a straightforward rectangle. So that's the difference with normal maps. And as Yorai said, if the whole point is that you're getting high resolution models, you don't need to do this anymore. That's kind of the benefit. You don't have to hack fake geometry because you literally have the geometry at your disposal,
Yeah, just to enrage online, regarding normal maps give you performance-free detail. They don't, they shift the cost. When you load a normal texture, you're loading a gigantic texture, usually the size of the original one or double, just to have all the micro details on the model itself. That's not performance-free, it's just faster for what you're trying to render with general technology in the age that we have it made right now. There are several reasons for this, but basically streaming a texture and keeping it on the GPU is basically faster than having models and figuring out which polygons, which triangles you'd like to render. And I'm not qualified to talk about it in depth. It's above my pay grade. But basically, with Nanite, you're shifting the cost back to the intended the easier to think about way, and you always have to make this calculation of, does my mesh actually benefit more from a normal map? How many subdivisions or how many details do I want to show in it, compared to how it would actually look like if I just dropped all the geometry in the scene. So different costs, but nothing is free.
Yeah, and 100%. Like that's one of those things. People talk about this a lot, but like everything's a trade-off. And the classic example being like, there's a question in performance once you start doing debugging on your games. where you'll basically say, am I CPU bound or am I GPU bound? What is the limiting factor to the work that I'm doing right now? What's taking up the most amount of my resources? And so a lot of this stuff is trade-offs in terms of something or other. So it is worth noting that, nothing is free. Texture memory isn't free. You'll have to load something one way or another. It just matters what do you have free resource-wise to utilize in parallel, effectively.
Sorry, real quick. When we're talking about this, are we sure that it doesn't use normal maps, the Nanite thing? I would imagine.
Well, it might do, but I guess my point is normal maps have a limit to how good they can ever look, because at the end of the day, it is like it's not real detail, right? And so they could very well use it, especially for certain kind of further away locations. I guess my point is you wouldn't need it. Like you could, but my point is the benefits you would get from normal maps tend to be when you're making a cost-benefit analysis and you want there to be less triangles, but you want to keep some level of fake detail. So there's like, it works really good on mobile, where it's not just about the performance of the processor, but you literally don't have a lot of texture memory to work with, right? You have to sort of also be careful. There's, it's a tough question, and it might do, but I don't see it being as, even if it is used, it would be used kind of like, there's a whole load of maps, right? Like, so I'm using normal map as a catch-all, but there are normal maps, displacement maps, specular, like it's different maps, and each map will do different things to your rendering, depending what you want to do, right? So it's, there's cases to use them, but the point of using a high resolution capture is that you don't have to fake these things, is kind of the point, right?
Yeah.
Your eyes rejoined. He had a technical issue. I just shared the page too, the link here with the details for people who want to read about it. It does look like you essentially just are avoiding having to use normal maps, though. They just generally agree. So I wanted to share the Lumen one, but first, so we got this working, I just want to really briefly share on screen the battler. So I've got it running in my background right now, and I added one other thing to it so that it now focuses and features each person that joins. So as you join, you'll get kind of like popped up on the screen. So they'll be back there. It's a little off my screen, but you can kind of see it. If you wanted to enter to win, it would give away a copy of JetBrains Rider. It's a 1-year license. All you have to do is pick a race and class. So just choose like whatever one you want. There are some new ones in there that do upgrades. So I grabbed the low poly monster pack. You can see like these little buds and the turtles and stuff. They'll all upgrade into different things, and all of the characters actually upgrade. They just don't all have visual upgrades right now. I plan to put in Andrew's guys, and what I was thinking there is we'll use blend shapes. Since instead of upgrades, you blend shape them down from like the small version to bigger and crazier, and kind of swap them out, make them get bigger. That would be pretty cool.
Yeah, that'd be cool.
But if you want to enter, just type in the race and species that you want. There's a whole giant list of different ones. There's a beholder, a bomb, a bud, a chest, a crab. They're all named after the models. Some of the new ones, a snake, a sunflower, and a wolf. Oh, and a dragon. So pick whatever one you want, enter, and then at the end, we'll do the giveaway. So that's all you've got to do. I'll leave that running in the background, so you might see yourself kind of pop up on the screen there as you enter, but then we'll jump over to talk about Lumen. So let me see if I can get my mouse cursor over here, get rid of that little help pop up there, and share the other screen. Welcome back, Yorai. Is it working better now?
Yeah, it's working perfectly fine again. I just wanted to say, because I missed it, my chance to talk about it at least, Nanite specifically says that one of its benefits is that you don't have to bake the normal map textures on the page that I tried to link before my internet died.
Oh, no, I linked that and we showed it too.
Great.
So, yeah, and that we linked that in chat if anybody wants to check it out. And it just popped up.
And they have they have detailed performance explanations, so do read that in depth if you take interest in that.
All right, so this is the Lumen video.
And just because it can be confusing, you've never heard these before. Nanite's the rendering bit, Lumen is the lighting bit, just for clarity. It's worth mentioning at least once.
So this is the Lumen showing Unreal 4, and then they're going to switch over to 5, and then show the comparison side by side. which I thought was good because Unreal 4 looks good, and then 5 looks even more realistic. You can see it's almost instant. And from what I understand, they don't have to change the textures or anything or the model's objects. It's just the improved lighting system, which is mostly, and again, I might be misunderstanding it, but mostly based around ambient light and bouncing and doing that well and proper so that you actually get the correct lighting that you would if a little bit of light comes into a room, bounces off all the walls and objects instead of the fake versions that we kind of work with.
That might even be worth talking about too. I don't know how much we've covered like how lighting works in games or rendering, right? That's already a big topic. Might as well explain it before we go into why this is impressive.
Yeah, I just want to say the full name for Lumen is actually Lumen Global Illumination and Reflections, so it's in the name.
But before you get to video games, what's really funny is once you start getting into game stuff, you realize a lot of it's modeled after reality because that's kind of how it works. It's just it's usually simulated in some way. Like if you're writing a physics system, the same calculations for gravity apply in your 2D platformer game than in reality. The difference is the rates, the numbers, and the complexity of the algorithm you're choosing. But the concepts are exactly the same in a lot of cases. Same goes with most things for how this works. What I mean by this is the way your light, your eyes process light, is that light is bouncing around and it eventually hits your eyes. That's what happens. At some point, rays of light bounce into your eyes, and what you're seeing is that sort of after image reflected whatever's there, which is kind of interesting to think about because you're never actually seeing things as they are now. You're always seeing things as they were at the time they bounced into your eyes, which is a weird thought. So when it comes to rendering light is if you have a physical object in a space. If you make a 3D game, and we're talking triangles, right? So start with, you have an empty nothing, and you want to build a rendering system. So you start by rendering a triangle. And so you basically say, draw a triangle on it, put a texture on that triangle, and then do another triangle, and keep doing this till you have a cube. And then as I do transformations to the scene, I rotate it around. But it'll be pitch black. You'll see nothing if there's nothing there. If you want lighting, you have to simulate that concept of the lighting bounce. So you've got your camera representing kind of your eye, and you want to bounce light around to effectively hit surfaces and then tell you what it saw. And that's why if you ever looked at the current kind of direction where people have moved towards all of this ray trace lighting, the reason why ray trace lighting is kind of interesting and high performance, and why even a small game, the performance tanks with it, and you might be looking at it if you don't know how lighting works, like going, what's the difference? I've seen games with lighting. I've seen these new games with lighting. Sure, they're a bit shinier, but why is this one like 10 times more performance required to do it than this one? Well, because the old way you light things was cheating. And you could do that by doing all the complicated stuff once, looking at the outcome, and then baking it into the textures, or baking it into the scene in sort of a light map or something like that. And what that does is it means you're not actually doing the calculations live anymore. You've gone and done the calculations once, and then you've put it into the textures. So now when you draw it, you're just like showing a picture. It's a difference between rendering it yourself versus showing it. Now, that leads to very static stuff. You can't actually change the lighting because you can only do the calculations over here. You can't do them when it's running. So you can cheat this by using sort of more smarter algorithms. So a simpler version of that, before you get to the really complex stuff, is by using light probes. And light probes are where you put a point in the scene and you sample the current light. So you say, this is in a bright spot, this is in a dark spot. And if I move an object through my scene, if I move towards the lighter thing, I add more of the light. If I move towards a darker thing, I add more of the dark. And if there's lights of different colors, you can sort of blend between them. Which is, on a side note, why when people put equidistant light probes, it drives me insane, because that's not what they're for. You're not meant to grid them. You're meant to put light probes where the light changes based on the depth of where it is, because as you move it through, it's meant to hit those changing points. So that's those two levels. And then you start getting into ray tracing. And once you get into ray tracing, you're trying to go well beyond the idea of even just baking lighting. Because in real life, different surfaces will, when light hits a surface, it will diffuse some of it, and some of it will hit your eye, and some of it will either enter the object depending on the texture and depending on how opaque it is. And so there's that concept, which I don't have anything light here to show you, but we've all done this as a kid, where you've shined a torch into your hand and you can see this sort of glowing oranginess of your skin where the light is shining through
surface scattering.
Yeah, subsurface scattering. And that's this idea that literally the light's bouncing around inside the surface of your skin and doing this really weird glowing thing. And that is a thing that you'd want your characters to have to look realistic. And so to do that, you have to simulate light bouncing around inside the skin, which is a crazy amount of complicated stuff, because you're not just saying light the surface of this thing, you're saying fire beams of light in, bounce it around, get the output, and then show me what happens after the result. And so all this being said, ray trace lighting, the reason it's so complicated is because you're actually saying millions of lines, bounce them around, see the output, and tell me what happens. And so the speed of this is why you tend to rate ray tracing stuff by the bounce count and things like that. How many bounces does it have? Because real light's going to keep on bouncing, right? But you have a limit to how much bounces you can do if you're trying to calculate it yourself. And then you've also got the concept of materials. And so this is where we get into physically based rendering, right? Where the actual items themselves have different textures and materials. So the way light would hit glass is different than the way light would hit concrete. And the way you will perceive that will be very different. And certain things, a good example being frosted glass versus non-frosted glass, the light is going to diffuse differently on those things. So all of this is to say, lighting is complicated, and more than complicated, it's very expensive. And if things are static, you can bake them in. If they're not static, you have to do this a lot of jumping through hoops to sort of fake the realism. Or you can just throw caution to the wind and say, we're going to render everything. We're just going to go absolutely crazy and actually treat it like real light. And then that's going to bring all the extra costs in terms of making good textures, setting it up correctly, setting the light correctly, setting the exposure on the camera correctly, and then you start getting through this whole pipeline of things. Now, that's not to say there isn't hacks you can do further. If you're really interested in this topic, when ray tracing was first brought into Minecraft, there's a creator, Sonic Bloom, or also the Sonic Ether. Yeah, Sonic Ether. They've done like a big thing explaining how it works and how they've set things up. And then there's also the RTX stuff in the official RTX Minecraft stuff, which has videos, which will explain all the path tracing stuff. And you'll see that there's still hacks they're doing to like minimize the amount of rays and to average out position, so you're not doing every single real life ray and a whole lot. But the point is, the reason why when people see like Doom ray traced takes more performance than like a modern game running at high resolution without it is because the difference is you're physically rendering light as a concept, not just individual. It's like the entire concept of light is being rendered. And so, yeah, that's what we're talking about. And that's why this is a big deal, because if you don't have to deal with that yourself mentally and you can just make something and have like light work, that's kind of magic, you know?
So I just want to add a few more things about it. If you're just thinking that using dynamic lights without ray tracing and all that is performance and magical and everything that you ever hoped for, it's not. There's a lot that goes into making even dynamic lights in default Unity, say URP, Universal Render Pipeline, go looking nice. But basically speaking, when you're just trying to render dynamic lights, what you'll do is you'll draw the mesh with the light being passed into the rendering code for a pass, and then you'll do that for every single mesh being affected by every single light, which is why in URP they gave you a very specific light limit per object. That tends to be unideal and unappealing to a lot of users, so a different technique in the middle before you get into the ray tracing is deferred lighting, which is you let all the lights draw what the surfaces that they hit would look like as one go, and then you let everything sample that, and as a result you'll get a lot of very uniform lighting. You can't use specialized shaders because you're not drawing every single object for every single light. You're drawing all the lights once, and then you're letting everything else use it. And that lets you go to insane light counts. For example, Genshin Impact has 1,000 lights in a chapel demo in one of their GDC talks because they're using deferred light for the environment. But it's not ray tracing, it's still hacking, and there's a lot that goes into there. It's not, say, casting shadows or figuring out that edges are darker because the light gets diffused and keeps bouncing in the corners a lot. Yeah.
This got quiet real quick. Sorry, I was in the process of also fixing the battler while we got to talking about light. Because I had accidentally made all my guys spawn on top of each other. Let me show real quick.
So I guess let's just go into a few of the questions here. There was a question regarding light probes being deprecated now. They're not. Again, different technologies, different outcomes. If you have a static scene, definitely most performant to use the light probes and just not caring about everything else. The less light probes you have to use, the better too. Again, as Jason mentioned, just putting them where the light changes actually matters. But if we're going on the other end, Lumen tries to give you global illumination, which is the concept of just until now letting all the light bounces happen globally instead of just say rendering what's on the camera or letting lights do a single pass direct. Actually, did you explain global illumination and the concept of
I
direct
didn't
lights
know.
versus? Yeah, okay, so let's get into global illumination because it's Lumen global illumination and reflection. So generally speaking, when we're trying to cast a light in standard rendering, you will do a pass of saying, in a nutshell, because I don't feel qualified to explain it fully, you're trying to draw a texture of light into everything else, and of course light obfuscation can happen. For example, if one object is in front of the other, it will mask the light that you show from it, and that is called the first pass of light. But then there's a problem with that, because if you have a box and you draw sun straight into the box up down and something is obscuring it, the parts that are under will not get any light. So the concept of light bounces occurs, where the ray of light, so to speak, would go in and then start bouncing and end up filling the light here. And this is what's called global illumination, illuminating past the first pass of light. And global illumination is very expensive, which is why in general games up to this date, it tended to be baked only or had a lot of memory cost just to have memory of different states of global illumination possibilities, so that if your light changes, the global illumination for the place that you're looking at would also change. It's not trivial. It's a lot of complicated code, and if you're trying to do it in Unity, there's like one solution that would literally take up 100 gigabytes of memory for the dev environment just to generate the global illumination space. Lumen, on the other hand, is a new approach to global illumination, which I don't feel very qualified to talk about, but it's way more performant and it lets you get the benefits of global illumination from anything within the scene in real time with minor delays. Very important to mention that part. And that gives you huge benefits, because one of the best things with trying to simulate light bounces perfectly, specifically with global illumination, is that some objects have glow to them, emission. If you have a flashlight in a real world, you're emitting light from within the flashlight and you're expecting it to go everywhere and light up the scene. Or if you have a glowing orb of magic or anything like that. That cannot be done with standard rendering. You're placing manual light sources, and this is a lot of heavy work to get it all looking exactly as you want it, which is why...
And even then, it's worth noting it doesn't
yeah.
always work the way you want to, because there's stuff like in real life, you have a light, which is like a bulb emitting, and you put it into a socket, and the socket is going to bounce the light around the room. But the actual, like the lamp shade you're using or whatever else you're using will either diffuse it or will change the way it looks. And so, funnily enough, sometimes just putting a light in where you'd normally put a socket will not do what you think it will, because it'll like your own like container could break the way the lighting looks. So sometimes you'll cheat this and you'll actually do things like a cookie, which will cut the light to make certain shapes. But I guess my point is sometimes that this, based on what I was saying, you might use an emissive material rather than a light. In a lot of cases for like office ceiling lights or something, it simulates better if you just have like a rectangle that glows rather than a point, because a lot of lights in game engines will be point lights, and in real life lights tend to be like, there's area lights, there's other different kinds of lights that tend to have a surface area or shape or diffusion that's not like a single point or a spotlight or something.
Yeah, I mean, in general, most lights have shapes. If you're even just looking at a campfire, every single spot of the fire is a point of light. You can't have light with a perfect shape of fire that's emitting and moving and doing everything a fire does easily in games. So you tend to just drop a single point of light and have the hope that everyone will buy into the fantasy that it's actually doing the entire lighting nicely and kind of uniformly as one would imagine fire would. But with Lumen, or rather with global illumination, where you actually have rays of trying to figure out how the light gets casted and how it would apply to the entire area, you get the benefits of having everything look a bit more accurate. And with Lumen specifically, because it's in runtime, you can have moving characters with those glowing orbs. And as they move the glowing orb around, the light of the room will change with the glowing orb. So it's fantastic to mimic realistic lighting. Ow, my ears.
Sorry, I didn't mean to blow out everybody's ears there. I was just kind of giving people more of the visual of it too.
So I just wanted to point out, yes, there are area lights in Unity. I think they're only available for HDRP right now. I don't recall they added them to URP, and they definitely weren't a thing in Burp.
Yeah, it's funny. I was actually writing a comment to respond to that. I was also going to say, even if there are, yes, they're in for different cases. Like there's been baked area lights for a long time. It's just whether or not for the runtime stuff. But its use case, it's very heavy for what it is, and it's great if you're doing like a doorway, which is a really nice light stream coming through it. But my point was, if you're using installation lights, like in a lot of, again, offices are a great example. If you have mood lighting or accent lighting or that kind of thing, you don't want an actual area generating light. What you want is a surface area generating light, and to do that, you're better off like having an actual shape and then having it emit, you know.
So URP does have area lights. I was thinking about a very early version where it didn't. But yeah, in general, Unity isn't that well off with the light modes it has in general, especially when you're looking at the fanciest tech available. And also, I just wanted to point out the difference between path tracing and ray tracing we had earlier. So generally speaking, we have the technology these days, the strong enough GPUs to send a ray from the camera and let that bounce and try to figure out exactly how everything looks within reason. Depending on how big your screen is, we try to send less rays and then blur the results out so that we get rather good lighting, but then there's shadows, inconsistencies, because our rays and our models and everything else isn't perfect. So there's a blur pass on the shadows, and if you're using HDRP, you can actually control this and tweak it and try to figure out how you like it. But there will be this concept of noise and imperfection. We still don't have the rendering capacity to just mimic the real world within the game in regards to lights, and we only send the rays from the camera and hope that it will hit everything it has to hit for what we're seeing. But in the real world, that's not what happens. There's two rays that get casted. There's the light emitting rays that will bounce and light up the area, and then there's the eye trying to grab what to look at after it's been lit, and that's called path tracing. Path tracing is way more complicated. We're still very far out from it. Even a simple game like Minecraft gets a lot of problems trying to do perfect path tracing.
Yeah, in fact, actually, that specific video, the NVIDIA video that they have goes into vivid detail showing you the noise and the various solutions they're doing to tackle it.
Yeah.
This is another side note because I think it's a fun thing. Rays in general are one of those things that if you don't think about, just like ray as a concept of like is used in so much in gaming that it's kind of crazy. That there's examples out there where you can use like I forgot, I think it might have been Coding Train, but I remember seeing a video at one stage where somebody basically built their own renderer just by a really simple example where they did sort of a Doom style geometry or just like a basic environment of a bunch of textures, and they physically rendered it themselves using the rays, right? So you can write your own rendering with rays as well. It's a fascinating topic to say that a lot of the stuff out there boils down to the technology is still roughly the same. Points in space, distances check, do something, rendering, drawings, it's even sound, right? If you're doing a lot of sound stuff, you're bouncing rays for attenuation of the audio and how it plays out. The technology is roughly the same in almost all cases. It comes down to how do you optimize it so you don't have to do every single ray? Because that's where the cost is. You want to avoid, can you average things? Can you get samples? Can you bake certain amounts of data out instead of having to do it all live? And that's why marking environments and things in game engines is important, because if you mark an object as static, it's not just saying, oh, this is good for performance. This is telling everything which does anything to do with checking positions and movements, this is possibly bakeable. Unlike if it wasn't static, then it mightn't be bakeable. So it's just worth noting that rays as a concept, it's worth looking into how they approach a lot of these technologies.
Yeah, and also to the person asking if there are many ray tracing tutorials for Unity out there, there aren't. It's a site that's genuinely underexplored right now. There is one person making tutorials for ray tracing in Unity that I found pretty good right now. That's the GameDev guru. So if you look up the colorful side of ray traced colored shadows in Unity, you'll find some stuff about that.
So I've got the battler up here now, and people are starting to notice. I think that it shows like the most recent person who's joined, and it's trying to pop them up. Some of them are, of course, I've ran out of spawn points because we've got way more entries than we've ever had. So some of them are just kind of like stacked up behind the scenes. So I think I'll probably start this giveaway a little bit earlier just to make sure that we actually make it all the way through, since it's we're at double the normal entries. By the way, everybody who hasn't entered, all you have to do is type in the race and or class that you want, and you'll be in there to enter to win a copy of JetBrains Rider. It's a 1-year license. There's also a set of the scriptable objects. If you're curious what the differences are between the races and classes, I put them up on game.courses/battler. You can download the scriptable objects, pull them into an empty project, and actually look at the stats if you're curious. You won't see the code for it, but you'll see the stats for what's set on each of the characters. Anyway, I just wanted to make sure that everybody knew about that and entered. You definitely got to add in a bigger arena. Maybe it needs to be like a giant Colosseum, like in Italy, like in Rome. Get like a big old Colosseum where they're all around it.
Yeah, with 2 FPS, 2 whole FPS.
I'll LOD them. It's fine. Just enable Nanite.
I'm pretty sure your animator capped right now on the CPU.
No, this system's beefy. It'll be fine. It's not doing great, but it'll be fine. It's actually Chrome that's killing my system right now. Surprisingly, it's not Unity. Unity's not really doing anything. Just Chrome. I don't know what it's doing, but it's killing things. So I wanted to share that. If you wanted to enter to win, now's the chance. We got 167 people in there so far.
So you're saying there should be 160 something likes on the video, right? Is that what you're?
There should be at least 167, because if you look, that's how you get extra power ups, right? Yeah. You hit the like. I still need to add that.
So there is one more topic I wanted to touch on before we move away from Lumen, which is we didn't actually address the second part of its name, which is global illumination and reflections. So generally speaking, Lumen does black magic to get the good quality level of reflection that it
well,
has.
before we do that, let's do the brief same thing. So I think it's worth doing the summary. Now, this would actually sound very familiar, and like I just said, the technology boils down to the same thing. Reflections. How do you get a reflection on something? Well, you bounce one into the other and you see what it looks like, and then that's going to be costly. How do you avoid that? Probes, right? So now, just like light, there's reflection probes, and reflection probes do roughly the same thing, where you basically have a shape in the middle. It's like putting a little mini camera, and it will capture whatever it's seeing around it. It stores that, and then anything which needs to have reflections, like water surfaces or anything like that, you can then effectively reflect that into the water by sampling whatever the probe is. So but now we're past that stage, but that's my point. Is it's the same technology, right? Conceptually, a lot of this stuff works the same way.
Yeah, and generally speaking, because you're trying to figure out the entire rendering for this single point, you're keeping huge textures just for that, and you're not just keeping light colors. So when you use reflections in games, something that would be very common is that you'll see windows reflecting the environment, but never the character. And that's because it's baked reflections, and the character isn't part of the baking process. The character is.
And by the way, so if you want to see this in reality, how many times have you seen a game where there's a mirror and the mirror reflects the room behind you, but not you? And that's exactly why now, because that was baked as an image rather than like real time bouncing anything to reflect it.
Yeah, and actually in Uncharted 4, when I just started playing and I saw the first mirror and Nathan Drake was in the reflection, I was like, oh my god. Because that was entirely uncommon for games. And even if you go in Genshin Impact and look at every window ever, the character isn't in there. But the entire environment will actually react to the lighting because they do this interesting thing where they update the reflection probes on a deferred cycle once in a while. But they're still excluding certain things that won't look as right because the character can animate really quickly. If the probe right near the character isn't updating, you'll see the problems.
And not to mention, depending on the kind of game you're doing, you might have a character who the model that you're actually using has no head, for example, because it might just be the arms and body, and so the reflection that you see will be this comical, like if you ever look, my favorite example of this is Mirror's Edge. If you look at the character model for the character in Mirror's Edge, it's a nightmare. It's like some eldritch, horrible monstrosity, because in order for you to get an FOV, first-person angle, of arms and legs doing the sprinting and running, the dimensions of that character are laughable. They're inhuman dimensions for the arms and legs, but that's what you get for like the first person perspective. And so if you're doing a reflection, even shadows, you want to make sure that it looks good. And so sometimes there's actually a different model altogether being rendered just for the shadow or just for the reflection or whatever it is you're doing. So it's worth noting as well that even if it did render your character, it might not look like what you think it looks like.
Yeah. So because reflection probes are really expensive, usually what you'll tend to have in games is just screen space reflection, where it's just the concept of you take the camera, this is what you have, and then trying to figure out the opposite vertical point to what you're trying to render, and that's going to, or rather, the opposite normal point to what you're trying to render, and that's going to be the reflection that you see, which is why in a lot of games, if you see any type of ocean or body of water, and you look down into them, you will stop seeing lights as soon as they leave the top of your camera, because you're tilting the view down. There's nothing in your screen anymore to reflect, and you're going to end up with like really weird artifacts. It's something that the more you get into VFX territory, the more you'll start looking for when you're playing games. There's Mirza Baig, maker of the Ultimate VFX pack on the Asset Store, has a Twitter account where he actively goes into puddles and starts jumping and diving and putting the camera just above the edge just to see what features of reflections the water has. It's really fun to see.
And just to like again double down on the mirroring of these ideas, that's screen space reflections. There's also screen space ambient occlusion, and so there's a lot of these technologies. They have like a post-processing rendering version you can do, which comes back to the trade-off costs, right? Because now you're doing it as a post-processing effect rather than any kind of either runtime or baked solution, which does have one really nice benefit, which is all of those fancy sliders. So all of those different options you can have in a game to turn on and off rendering options. If you're doing post-processing style effects, you give the person a lot more control over what they can toggle. You don't have to manually like code some complex swapping out solutions for other things.
Yeah. So reflection is really a gigantic topic, but basically Lumen's approach to that is a far more advanced version relying on the technology that they had to do to get the global illumination working in the first place, which lets you see a far more advanced view of most of your scene. And it's beyond amazing to see that they managed to get that. I'm really hoping Unity will get something equivalent. So
you want to take this question, Yorai, about who is Yorai, and maybe we'll just do a real quick intros for anybody who hasn't been here before.
Yeah, so I am the lead developer of Terraria, currently the lead programmer to be precise. I didn't start a game, I joined in after. I've been the lead programmer for 6 years, been in the company for 8 years. So yeah, working at Relogic, basically.
What about you, Andrew? You want to tell everybody about all your awesome stuff?
Yeah, I'm Andrew. I've got a lot of board games behind me. I run Infinity PBR. We make models and some tools, and a lot of tools that go with the models and characters, creatures, cool stuff like that for all your.
Some of them are on sale today, right? And there's links down below.
Yeah. There's a bunch on sale today, including the RPG Character Complete bundle, which is the big one. If you want to make an RPG, a fantasy style RPG, it's probably a good thing to purchase.
Yeah, definitely grab that one. We'll link that one in chat too if it's not already. I think it might be, but search for Infinity PBR and the assets where you find it too.
Yeah.
And then, Jason, you want to just tell everybody where your Ko-fi page is, or coffee page, and your Discord and all the fun stuff, or anything else you got cool to share?
Yeah, so I guess then as an introduction, I'm a software developer who does contracting and consulting in general. So I bounce around lots of other people's projects, offering tips and suggestions and things. That's my day job for the most part. And then I'm kind of slightly moving into educational space stuff at the moment. I like the idea of teaching a bit more. So I have a YouTube channel, which is just my name, Jason Story, Storey. And yeah, from there, there's also links to my Ko-fi page if you want to donate anything. And that's me.
Hey, you should do that and get into his Discord server. I have notifications back on for Discord, and I see the chats in there all the time, and they're interesting discussions about stuff. So
yeah, the chats tend to be very high-end coding stuff, so it's really fun to see what everyone's working on. There's also been some quite few discussions about game jams recently, because there's the Bullet Hell jam going on right now, and there was Ludum Dare a week back.
And I really appreciate too, there's a lot of people from different disciplines with different skill sets. So there's people in there who know way more than I do about shaders and rendering and networking and stuff. And so it's really interesting to be able to have a group of people who have interests that are tangential to yours, but more experienced in certain areas. So I admit the Discord is a very useful tool, even for myself, to sort of ask questions and talk to people.
Nice. Oh, and yeah, I'll introduce myself. I'm Jason. I've been making games for a long ass time. Mostly MMOs, some mobile stuff and VR stuff, and talking about game dev on YouTube forever. That's pretty much it. But while I'm up here talking, I may as well share and plug my stuff too, because why not? So the first one is a conference that's coming up next month for Unity devs. Just going to be going over all kinds of cool new Unity features, some of the tips and techniques and things that I think are useful. It's all talks that I thought were kind of interesting stuff and useful stuff that I wanted to learn about. Did I break this page? I may have broken it and added in my TBA one there again. But there's just lots of talks on things that I think will be helpful for me, or that I would have found helpful when I started out in Unity, when I was kind of like the first couple of years in there. So some of them, I'd say it's probably like half things that I'm really curious about, like the new Unity multiplayer stuff. And then some of it is just like things that I really wish I had known about right away or had gotten into. So that coming up. And then there's also, I'll share this right here. Just if you go to game.courses, just the homepage, got a little Easter sale where you can get courses and the ticket to the conference at a discount. So that looks interesting. Just go check it out, game.courses, or go to GameDev Guild, and you can see them in either one of those spots. But yeah, that's me. Should we pop up the giveaway? I kind of want to get it started before we jump into other stuff, and I thought maybe we could take some of the questions and go into some Unity stuff.
Go for it.
So let's. I'll screen share it real quick. We'll make it big, and we'll get it started. We've got 192 contestants, mostly wizards. So it's like, remember, I did buff paladin or bards and berserkers. So let me make myself into a bard real quick before I hit the button, and then we'll hit the button to start the fight. So what'll happen? I don't want to be a rat though. Let me change myself to something else. Let's be I'll be a bud. This is giving everybody a chance to quickly change their thing. So got a couple seconds to change into a different creature type. Wait, why am I still a bard or a rat? I don't want to be a rat. I'll be a crab. A crab bard. There we go. Now I've changed, and we'll start the fight. So for everybody who hasn't seen this, it's just an automatic giveaway battler thing that has all your characters come down. We'll fight in the arena in just a second as the round starts, and it's single elimination. As you get knocked out, you disappear. And if you win, you go back up there, and you get buffed now. So let's watch one of the rounds real quick. I want to see if any of the characters that have a visual buff show up. Let's see. Oh, Jason Story's in there first, and he won and got buffed. Look at that. He's a bigger wolf now.
Nice.
Look at you. And I don't know if you noticed your max health even went up, because you now scale up per win up to 3 wins. It's still the Pokemon character, so I figured I would go with Pokemon levels. 1, 2, 3.
When do you evolve?
As soon as you win.
Okay.
So you win a fight, you evolve, and realistically it keeps track of your win count and then multiplies your race or your species battle or stats by your win count, but caps out at 3. And then those species limits are a little bit lower, but they might be way overboard and crazy. I don't know. We'll see.
Yeah, okay. I was just wondering if there's
the
any...
dragon at the back upgraded as well. That guy on the right.
Yeah, he just buffed up.
Nice.
Now the question is, can any of these classes and races end at a point in which they have less than 1 max HP?
No,
multiplying
that's definitely only one of them has negative on the health, and it's only minus 10, so they can only get minus 30. Yeah, I was worried about that. I tried to minimize the negatives on the species ones.
Gotcha.
Just specifically because I was afraid I was going to break things. I may have broken things. We'll see. We'll see how well it works. I forgot to turn on the wait for YouTube option the first couple times, and I was like, why am I not getting any new players? Like, oh, these are all fake people because it's all based off of real ones. So should we jump over to questions and stuff now?
Yeah. Sure. Was there any question that you wanted to answer in particular?
Not anything real specific, but there were a couple that popped up. There were some real ones and some that were like this. When are we getting Terraria 2.0?
I don't know. I don't know if we are. I know I am working on a Terraria update again, but
oh, another the last update, the last update.
It's the Labor of Love update. So
the final V2 final revision update.
You know the phrase, the only thing certain in life are death and taxes? Well, it's death, taxes, and Terraria updates. I'm pretty certain there's nothing will ever stop that happening.
There was a question about 2D and 3D game making, and they're curious about how you would make a side scroller with 3D assets like Donkey Kong Returns.
Yeah, so this is actually an interesting conversation because it's one of those things which is not intuitive again at first. When you first start making game things, you kind of mentally divide in your head. There's 2D games, there's 3D games, and I'll make one or the other or whatever. And every so often you see one of these crazy isometric type games or games with a 3D background and 2D characters and think, whoa, how'd they do that? And the truth is, because it's all the same thing. The delineation that we make between 2D and 3D may affect some aspects of rendering and some particular things. But the truth is, in most cases, it all boils down to the same thing. Whether you're showing an image or showing a 3D model, you're still rendering a thing on the screen. And whether you're moving it around, you're either moving it using X and Y or you're moving it using X, Y, and Z. So the number of differences between a 2D and 3D concept is actually surprisingly small. There are concerns that are different in terms of how much, like, rendering 3D costs a lot more than rendering 2D, and some of the math gets heavier. But at the end of the day, like, from your perspective, it's pretty much the same thing. And so these kinds of games which are 3D platform or 2D, you can literally make a 2D game, make the camera 3D, and just place 3D models around it, right? Like, conceptually, it's exactly the same kind of idea. It's interesting because it's one of those, same with camera. That's another thing too. I find so funny. When you first start looking at games, you mentally delineate first-person cameras, third-person cameras as these separate things. But once you start making games, you can kind of go, hang on a second. The camera is arbitrarily the position I place it. Do I want it top-down? Do I want it horizontal? Do I want it first-person or whatever? And so camera perspective, the only time that's important to you is things like fidelity of models. Like, you obviously will have a different perspective on how you're going to do the models in a top-down game versus something that's first-person. And when it comes to model optimization, there's the whole concept of culling back faces and things. If you've got a top-down angle where you're not looking at certain sides of the models, you might actually just cut out all the background. So there's no actual data at all there on the back of the models. So some of those things are concerns, but honestly, a lot of these things that people talk about, the differences between 2D, 3D, 3D VR, a lot of it boils down to industry knowledge about performance techniques rather than any actual differences in workflow. At the end of the day, moving a thing, raycasting a thing, playing a sound, all of these function the same. It's just the math might require an extra axis, or you might move from being, doing something which has, it just might get a bit more complicated in certain cases. Although, as an aside from that, it's my personal belief that if you're starting out, making 3D is actually easier, not because the math or the modeling is easier, but because the requirements you have to do to make custom content is less. 2D games require you to access and find images, and it can be very disheartening that it's hard to make something look good. But in 3D, you can put some cubes in a space and it's still entertaining as a space. And people often misjudge 2D as being either easier or lower effort, when it can be a lot more depending on the context. And so if you're starting out, it might be easier to make a 3D game because honestly, people are just impressed by a third dimension and it's quite straightforward to kind of get yourself started. But yeah, 2D versus 3D, not really that much of a difference.
Yeah. I think
Yeah,
oh, go ahead.
No,
I've done this before with my stuff because it's fun to see a character actually turn in a 2D space, even though it looks flat. So you use an orthographic camera, just nuts and bolts. Using an orthographic camera helps to make everything look more flat and 2D like, even though it's 3D. And if your camera is looking straight at, say, a cube, it will look flat. So you can add a texture on that, or you can use a plane, doesn't really matter, and then use a collider, a cube collider as the ground. You know, one thing you might need to do is make sure the character is always on a certain I guess position in the depth, so that if the walk, sometimes there's a slight like left and right and they'll get off and they'll fall off. So you don't want that. So you might have to code for stuff like that.
And physics too, it's worth noting, if you have something that's a physical rigid body, if you hit something, it's going to rotate weirdly. You might want to do what's called freeze a particular axis of rotation. So even if you hit it, it'll never like float off into the Z depth of space when it's actually a 2D thing. You know?
Yeah. So essentially all you're really doing is making a 3D game, but forcing things to stay on one line. And then you set the camera up so it looks more flat if that's what you want, or you do that whole you put the camera at an angle so it's still one line, but you can actually see the depth a little bit.
Yeah.
And then you could do crazy things where now you have the character switch, so now they're going forward and backward like the old Contra game halfway through, and then and now it's going backwards side scroller again. So
just to touch on that note, when you try to do that, what tends to end up happening is that you tend to build a curve, or rather a path by which the character will start going on. And then when you go forward or back, you're going on that path, forward or back. That tends to be how the bigger games try to do it. For example, in Nier Automata, there are walkways where when you start running, it becomes a side scroller. The camera goes like far away and you only move left and right, but the left and right actually changes if you go around the corner or anything like that. But in regards to the 2D versus 3D, I just wanted to touch on something that hit really home about how people think 2D is low effort and easier when it's actually not. In Terraria, in the 1.4 update, we decided that we wanted to add golf, and to do golf, we had to do a character holding something in both hands so that it looks sane, because up until then, we only had animations for the front arm of the character moving and swinging. So when we were shooting, we will just point the arm in a different way, but you can't play golf with one hand. It would look extremely silly. And one thing led to another, and we decided that we want to have the back arm move so we can grab things and then use that to swing golf or play a guitar where one hand holds the guitar and the other one strums. And that became a whole ordeal because we had to repaint all of the armors and character torsos in the game. We were talking 200 textures plus, whereas if you're only making a 3D model, you only have to make one animation. This is the amount of difference that it goes into. Once you start scaling a 2D project, if you want to make any change, you start to have to apply it to everything that change applies to. Whereas
and actually,
animations are free as soon as you have a rig model.
And that brings up a really, really interesting point, which will infuriate a lot of anime fans, but you'll notice this if you're into this kind of thing. At the end of the day, just like everything else, we talk about rendering. Anime is a great example. It's a cartoon. At the end of the day, it's pictures, it's frames, and people draw them. From the Disney days of animation, you're drawing individual frames one by one every single minute. And think about it. If something was rendering at 24 frames a second, that's every 1 second of time, there's 24 individual pictures being drawn. That's a lot of manual labor. Then later on, you get to the concept of tweening or in-betweens, which are effectively, you animate from a frame to another frame, and you kind of start to... Yeah, it gets into a whole thing about there's artists who do the keyframes, which is why they're called keyframes, and then you'd have the cheaper sea of younger artists whose job it is to fill in the images that go between the two. I bring all of this up to say that's very costly, and if you're a studio making animation, that can be an absolute nightmare because you're talking months and months of work for like seconds on screen, depending on what you're doing. So there's a trend in animation to cut it down. And so you might have seen these anime, which is kind of like weirdly 3D. And it looks a bit off and doesn't quite have the same polish and style as, say, like Studio Ghibli stuff used to. And that's an attempt at cutting the cost of animation by using 3D models and rendering them. And that's a perfect example of 3D is cheaper and easier there, because rather than having to manually draw every single step of every single frame of movement, you can animate a character. And then there's still cost, and the cost is now in rigging and making a character and doing the animations. But now, if they're doing a dance or jumping around, you're only having to re-rig the character, right? You move it and animate it. You're not having to draw every possible change of every possible thing. And if you make changes then as the project goes, you can just change a single thing and the whole thing is still working. So games do this too. There are certain tactics in certain games where you will actually it'll look like a 2D character to you, but it's actually a 3D model. And the 3D model is then being rendered in a certain way where an effect or a shader filter or something is put on it, which makes it look 2D, but what it's actually doing is being a 3D model, which has a lot of cost benefits for the person making the game, that they don't have to make individual drawings for every new weapon type or every new animation. So there is pros and cons. Sometimes it looks good, sometimes it looks bad. There's also the concept of puppeting. So certain games as well have this look where a character has been split up into pieces, like the upper arms, the torso, and whatever, and then you rig it in the same way you would rig a 3D model. So rather than individually drawing every like frame of the jump, you would then animate and rig the hands in the same way you would do with a 3D model.
That's
so
kind of this bone animation thing that's popped up here, right? The 2D bone stuff in Unity.
Yeah.
So
there's a lot of different. My point is, there's a lot of different ways which you can handle this, and the relationship between 2D and 3D is not as sharp as a lot of people think.
Yeah, I was just gonna say that I've seen that in all the cartoons too. Like half of the cartoons my kids watch are definitely 3D models with just a nice little effect afterwards to make it look a little bit flatter, or sometimes not at all, and it's completely 3D, and they like zoom around and do 3D animations in there, and you tell the whole thing is just done there.
So just to touch on that, in anime they also cut costs a lot because they have the problem of drawing in 2D and not being able to adjust as much. So you'll see a lot of frames where the characters are only moving their mouth and nothing else in that scene. And they'll reuse the same animation and scale the characters a bit down a bit or something like that, just to cut down on the amount of frames they have to render within every episode. It gets really bad about the lower budget feeling ones. This is what you'll probably see if you try to go step by step to why it feels low budget. And yeah, so I just wanted to touch on the 2D bone before we move to this question. So with bones, there are still plentiful of issues that you might not consider, specifically in that you cannot change the order of the layers. So you still end up with having to think about everything looking just right as you layer the content and move it around with the bones. This is not a problem you get with 3D. If you have a character with a back hand, but you put the arm forward for an animation, the arm will be forward. In 2D layers, it's not going to be like that. You can't change the order dynamically as easily. And specifically in pixel art, it's way more complicated to get good feeling outlines or specific looks when you're trying to rotate a pixel. It's not as clean looking with the final result, so you have to rasterize the frames. So this question, do I get to answer it?
Yeah, you want to read it out loud first?
Yeah. So love you guys' content. How would you approach the building of building an ARPG? Kind of like Kingdom Hearts. I feel like FSM turns into a nightmare very quick. So I have a bit of experience with this question, specifically because I've been trying to make games like that as a hobby for years now.
Can you first tell everybody what an ARPG is, for anybody that doesn't know?
Yeah, I'll actually clarify all the terms in here. So ARPG stands for Action RPG, which RPG means role-playing game. But generally speaking, you'll get a hero. The hero has a goal. The hero has to go do things. And that you play the hero's role, doing the things with action, usually combat, or a lot of excessive movement involved. And those games tend to have a lot of intertwined systems to make the action feel very robust, and you have to care about their responsiveness. And usually, if there are any enemies in these games, they will end up as very complex enemies. They will do dodges, they will try to block you, they will jump, they will surround you. Bunch of behaviors. Now, FSM in that message means finite state machine, which, generally speaking, is something that you use in Unity a lot if you ever worked with the animator. It's a graph by which you say, this is a state I am in, and I can move to other states, and as I move between them, do stuff. So a character can be idle, the character can be running, the character can be jumping, the character can be landing, and the character can die. Those are all states. The state machine lets you traverse between those states with a visual display, something that's easier to think about than raw disconnected code that starts checking everything.
And it's worth noting as well, the F in that finite state machine, the point is that there's different ways of things having states, and a finite state machine has a finite number of states. An example is a state machine isn't about characters or animation. It's the concept of a thing with states. So your telephone has a state machine. It is either during a call, not call, receiving a call, right? These are states. They're finite. There's only a set number of them that there can be, and there's transitions from states to states. And state machines can get massively complicated or very simple depending on how many transitions or edges there are between them. But at the end of the day, it's basically like a graph. It's a graph of from here to here, here to here, under which circumstances. Then there's concepts of directionality, whether it's a directed graph or not. It starts to get pretty heavy. But yeah, FSMs is probably one of the most straightforward and most applicable versions of AI for anything. But there's a lot of other ways of doing it.
Yeah, so this is what a finite state machine is. Perfectly spoken, Jason. I didn't get to the finite part at all, and you covered it way faster than I could. But generally speaking, Kingdom Hearts, an action game that has you swinging around a sword that looks like a key at a bunch of creatures that will try to use a bunch of attacks on you, and the character itself has a bunch of attacks of their own, and you try to command the character to do a lot of advanced actions, for example, throwing the sword or hanging on ledges, and then from the ledges jumping and doing special attacks. Specifically speaking, Kingdom Hearts is a very big game working from Disney and Square Enix, so there's a bunch of content in there, and the enemies are quite varied, so saying an FSM would become a nightmare very quickly is right if you're thinking about AI, which is why I assume you brought this question up in the first place. So I just want to say there are different tools for different jobs. Characters definitely preferring finite state machines because the character cannot be animating two things at once as easily, usually, or rather, you cannot move from an animation by which you are, say, in the middle of attack into all the other animations as easily. There's usually a flow that a character will go through. So finite state machines are perfectly okay for that. Now, for making the decisions each character would make, say an enemy tries to go and attack you or dodge you or just wait around or walk around you, Kingdom Hearts specifically, if you want to know, uses behavior trees. Specifically, if you go to the Kingdom Hearts free modding Discord, you can literally see a tutorial that's like 1 hour long explaining all about behavior trees in Unreal Engine 4 and how to make a new enemy and what do most Kingdom Hearts entities do regarding making their choices. Now, regarding what the difference between a behavior tree and a finite state machine is, Jason, do you want to take that one, or should I try?
Oh God, I'll try, but yeah, it's so yeah. So all of this boils down to you are making decisions. We talked before about how we're simulating reality in a game engine, and all of it is different approaches to how do you think about a problem and solve the problem. An FSM is an example of a small problem space. There is things can be either A, B, or C, and you can get from A to B, but you can't get from B to C, and so on. So you basically can structure the steps. And what you do is in each state, you say, if I'm in a phone call and I put the receiver down, I have changed from one state to the other. So the states themselves have their own nice little start, update, and exit. And on exit, I do this, and update, I do this. This is very linear and very straightforward because you're moving from one state to the other. A behavior tree is more like a dialogue tree, is a good example, is where there's not a direct flow of A to B to C, but there is a structure as you flow through it. And so I talked before how that's a state machine is like a graph. You're from one place and you take a direction like a road to take different paths to get to new destinations. A behavior tree is more like solving a problem incrementally. Imagine you were given a box to open and you didn't know how to open it. You might try a bunch of things in sequence. You might go, I'll try to open it. Doesn't work. Okay, what if I try to jiggle the lock? Maybe that doesn't work. Maybe I'll shake it. That doesn't work. And you'll iterate a bunch of steps until something happens where it opens and you're happy. And so a behavior tree is kind of like starting at the root of a tree, and you try different things. So your AI might go, is there somebody near me? Okay, there's not. I guess I'll wander around. And it'll basically have this structure where it's asking itself questions. And you take a question and you follow down this path of this tree, depending on where it goes. And if a tree fails, it might go up a chain down to the next branch. And so you branch the tree to get considerably more complex. It's still not the easiest solution, and it's still got a lot of complexity to it, but it's easier to reason about because you're not stuck with the limitation of one state and a direction to it. What you've got instead is this sort of more free-flowing feeling idea of moving from one place to the next by checking different flags and states of what happens. Is that any good? It's very hard to explain the differences it does too.
Yeah, I can try to go for a bit of a simpler implementation, if you will. So generally speaking, behavior trees have a bunch of decisions to make and then actions to take based on these decisions. And you're solving them based on priority. So your first priority is making this check, say, am I in danger? And if you are in danger, you step down into a set of smaller choices. Say, am I about to die, or can I defeat the source of the danger, or whatever have you? And the author of that behavior tree gets to decide what has the most priority in each given layer of priority checks, leading into picking actions. And in a game, say, like Kingdom Hearts, what you'll have is, do I have, am I in water? If yes, do swimming decisions only. For example, is there a danger near me? Can I swim to that danger and attack? If I can, do that. Also, if I can't attack right now, am I about to die? Can I heal myself? If yes, heal myself. If I can't heal myself and I can't attack, try to just run around in circles or something stupid like that. And then if I'm not swimming, well, that priority is completely slipped off the mark. Start doing other things. You are not ever in a specific state. You keep making decisions based on the available information to you, and then you just execute what you can. Now, one thing that's under discussed with behavior trees in regards to AI is that you can make specific nodes of that behavior tree stop working after a while. For example, if you don't have enough mana, or if this node is now on cooldown, which you can set from within the behavior tree action execution. So you can say, can I cast this ability? Is it off cooldown? If yes, cast the ability, put it on cooldown. Now I can't use it for a while, and this behavior tree priority is no longer available to me. And this simplifies how your enemy will act a lot. Go ahead.
Yeah, and depending on which implementation of a behavior tree you're using, a lot of them will come with building blocks that kind of feel like Lego. There'll be things like weights or sequencing, or you might do all of the next actions, or you might do only whichever one succeeds or whatever. And so you're kind of building this problem-solving machine by saying, try these different steps using these different sets of rules. Yeah.
So we have a winner on the giveaway, but I think something bugged out. So I might run another one and give away another thing after this. So Ember Wolf, congratulations. Send me an email, jason@game.courses, and I send you over the writer code. And I had to figure out what happened with, I think a couple people didn't get to fight right because of some bugs and way too many people joining. So I want to figure that out and see if we can maybe run one more where everybody will be re-entered and have another chance. So see how that goes, if I can figure out the code. We'll see.
Yeah. So regarding the question on screen from Durai, which is the best behavior tree in Unity? I bought Node Canvas, but it needs the Flow Canvas too, so I bridge it with Playmaker. Is there a complete solution for behavior trees? I have not tried extensively any of the behavior tree solutions on the asset store, basically because I never force myself into a situation where I need one. But I did see some popular games using Behavior Designer from the asset store.
Yeah, I've used all of them at some point. Behavior Designer is the most popular one, and it's very good. It does a lot of stuff. It even has like preset action states for things like AI and for having a crowd of characters move around and do stuff. Personally, I actually prefer no canvas. Just like visually, I like what it does. I think it's a lot more. It feels to me more like, to quote the name, more like a canvas, because it means I can build my own nodes in a way that feels, it feels a lot more less out of the box, but you get to play with it yourself more and like use its. I like its interface to build my own nodes effectively. You can still do that in Behavior Designer, but I find Behavior Designer works more like a sequencer in my mind. It's very much like all of those sequencing steps, but the way you would do it in something like Node Canvas, it doesn't feel like it's built specifically with that in mind, but it means you can write your own very specific nodes and create your own tree. It's also why like I don't use Playmaker for that either, because it's very much, there's lots of pre-baked nodes for like pieces of the puzzle, like using things to do with setting values and renderers and whatever. Well, I prefer to make nodes that are like patrol and, you know, collect whatever, and then build up a state from there. But that brings up, somebody mentioned in the chat a question about GOAP, which I thought was a really great transition to this, because that's the next iterative step from here. So I love this topic, because up until now, what we've talked about is I have a character I want to exist, and I'm pre-baking the answers. I'm saying this character has the ability to block, the ability to attack, the ability to do whatever. And under this condition, you do this. And when this happens, you do this. If you're too far away, you run away. If you do this, like you basically write its behavior physically into the code. The problem with that is it leads to very rigid and specific behavior. Works fine for like shmup, where you've got enemies swarming at you or whatever. But if you want intelligent, more advanced games, behavior trees allow you to have very complicated behaviors, but it's only an extension of the same thing. It's like I have various destinations, and I am writing and physically drawing map paths to solve problems for each individual case. The next step is goal-oriented action planning. And what that is the other way around. Rather than starting with, these are the possible solutions to solve problems. If you come up against a character who has a melee weapon, but you've got a gun, shoot from range. If you've got a melee weapon, they have a gun, try to get close. Like, you're writing these in, you're building your paths. In reverse, goal-oriented action planning says your goal is to kill them. That's your job. And here is a bunch of stuff about the world. Do you have a sword? Are you close? How's your health? And whatever. And because, like I said, it's a graph. If you've ever done any kind of path finding, just like solving a maze, the way you do that is you use graph theory, and you have a start and an end, you have weights, and you effectively traverse and take the shortest path. And what's cool is you can apply that same logic to AI. So what is the correct path to my outcome? If I want to kill the enemy, what is the cheapest weighted path to get me to there with the tools at my disposal? And what's really clever about this is you might have a path which says run at them with your melee weapon, but there might be a gun on the ground, and there might be a cost to walk to the gun, a cost to use the gun, but the cost to use the gun is cheaper than the cost to use the distance of adding the run plus the melee. And so it might decide to, even though it can run at you, rather than taking that path, it will pick up the weapon, take cover, and shoot, because that outcome leads to a cheaper cost. And you as a designer get to weigh the costs of, here's how much it costs to get in the cover, here's how much it costs to run away, here's how much it costs to be, you know, to get close or to get far or whatever. And so you end up with this really interesting AI where it starts to like resolve and do things. And an example of this might be in Breath of the Wild, where you can take a weapon out of enemy's hand and they'll kind of like look a bit shocked and then go, okay, what do I do now? And it might have to go acquire a new weapon, or maybe it runs away and it reacts more dynamically because you didn't tell it in this circumstance do this. You said your goal is this, and here's a bunch of states of the world, and string together a path based on the things that make the most sense to you to do that. And then this gets even further when you start talking about having composites of this. And so there's a particular version of this that's even more complicated that's used in games like Horizon, where there's individual goal planning, and then there's hierarchical task planning, which is effectively a herd is making a decision of what it wants to do, and the members of the herd are trying to do its job to support the herd. And that's why you get some really interesting AI behaviors. Like if you kill all the members bar one of a certain herd of animals, the other one will go hunting for a party to join. And depending on the goals of the other party, they might accept the new member if they're missing a member they need. But if it doesn't support a goal they need, they're not going to accept it. And so you end up with this much more organic feeling behavior. But the cost of this is it's very intensive. We're back to the whole concept of like ray tracing. You're now doing problem solving dynamically for every character against the world, against every possible weapon it can pick up, every character it can fight, every cover it can see. And so you end up with the same problem. And so games which have a lot of scale to them, they will cheat this. So this is the same behavior that's being used in something like Shadow of Mordor, where you've got tons of enemies all trying to figure out what they're going to do. Do they hunt you? Do they climb up on walls? Do they shoot you with arrows? But the kind of secret sauce here is you have a pooling system where about 30 units can only ever do this. The rest of them have a dumber kind of AI of just generally hanging around or being close to you or following other characters. But about 30 of them are making decisions, and then those decisions trickle down. And that's some of the ways you can cut down on the costs of this really heavy, high performance, every character like going full calculation of what it's doing. So there are costs to this too and trade-offs. But it seems like a lot of games are moving more towards this goal-oriented action planning because it leads to a lot more organic feeling in the AI. But that's not to say behavior trees aren't great, but it's specifically the kinds of games. These are all different problems, and some people see this as an evolution in terms of one's better than the other, but it's more they solve more complex problems. And if your game doesn't need action planning, don't do it for the sake of it. You're far better off having reliable state machines, because same with physics. Some games, you could do a whole physics engine, but now the platforming is unreliable. My personal rant with I really hated that in Ukulele. They tried to remake Banjo-Kazooie, which has a very like static, hard-coded physics system, and they remade it with a physics engine with Unity, and everything is slidey and slippery and unreliable, and it just didn't have that same tightness of controls that you expect from that kind of platforming game. So use the right solution for the right problem. Don't just use the fancier tool because it's there.
Yeah, and I just want to clarify 2 more points regarding behavior trees and action games. Specifically, those games tend to try and promote player mastery by understanding what the enemy does, and the more intelligence you give the enemy, the more difficult it is to understand what it's about to do, and the more difficult it then becomes to feel masterful about the game and knowing what to do when you're recognizing a situation. And also, because behavior trees are simpler, you declare what the priorities are for the character at any given point. You are more prone to having soft locks or issues because you didn't plan for them. Whereas goal-oriented action programming planning does the figuring out of how to get the desired state no matter what. For example, if you just took the behavior tree and you added a very early node that said if there is a chair, sit, then the character will just try to sit regardless if it's in combat or whatever have you. And if there's no cooldown to the decision to sit or something else goes awry, the character will just sit there. And even though Minecraft doesn't actually use that, there is a very funny thing that happens in Minecraft where if an enemy moves near a boat, they will sit in the boat. Regardless if they're chasing you, if they're trying to murder you, they will just endlessly sit in the boat. So that's the kind of problems that goal-oriented action planning will solve for you.
There is a trade-off for that too. Yeah, exactly. Because the problem with a behavior tree is you have to understand your edge cases. You have to make the decision. If I am near this guy and I only have a long-range weapon, but I have no ammo for my long-range weapon, but there's a melee weapon on the ground, do I decide to go and get it, or do I run away because I have no ammo? You have to specifically like know the cases where those things are going to happen. The beauty of a goal-oriented action planning system is it's tree traversal, and just like with a maze, you can check if it evaluates. You could say, given this starting point where you have these states, and given this outcome I want, is it even possible? Is there any possible scenario that can get you from here to here? And you can run that, and it'll get a thumbs up or a thumbs down, and you could say, actually, no. If there's this, there's no way I can kill the enemy. If there's no weapons nearby, no ammo nearby, I'm too far away, I'm on a different island. And like you could specifically like set up this set of rules and validate each case, which makes it much easier to test these really weird bugs because you're not going to be in a scenario where the AI is like, you never told me what to do here. I'm just going to sit in the chair, right?
Yeah. And actually, to get a tiny bit more into that, behavior trees only solve the current situation for you. They're making a decision at the given point. Goal-oriented action planning will actually let you figure out the entire state, usually into the future, as it were, graphing out what you can do, and you don't actually have to execute it. You can just say, figure out a plan, show me what the plan is.
And another thing too is like these things are not mutually exclusive. When you get really crazy, what we're talking about here is each of these solve different kinds of problems. So you'd be using a certain version of graph solving solutions for AI to traverse whether you're going to move around a space. You will then use whether or not there's safe ground or whether there's a path you can make to a location as a flag inside of a goal-oriented action plan to decide whether it's even possible to take that branching path. And once that branching path is chosen, the character might change its internal state machine state to change to something else to do what it's doing. An example of this might be Halo was using behavior trees for all of its characters, but it's not just the fact that they're hard coding these different states. They're doing it like a half and half, where the characters have a sensor system. And so the characters have, like in AoE, I have a radii for which I can hear enemies, and I have a radius for which I can see enemies, and I have various different behaviors, and those become inputs into the behavior tree system. So the behavior tree isn't sort of saying, if I am near enemy, do X. They're saying, if I can see enemy, do this. And so you're kind of getting into this weird mix of where does one end and one begin? And so it's not really about a direct solution. It's about, you can do, AI is just about solving a problem, and you can do it whatever way solves your problem, you know?
So,
Of course, I was talking while I was muted, but yeah, behavior trees have always felt super powerful and a little bit mystical to me. It always takes me like a day or two to feel comfortable again, understanding what's going on, getting you back into it. But they're super handy and really, really powerful. They're actually got a goal, GOAP. I can't even get my acronyms right. A course on exactly that. I found it extremely helpful. Goal. Never mind. Andrew, do you care if people use your assets in Unreal?
Yeah, you can. You can use it anywhere you want.
Somebody had asked earlier if you were going to be angry that they buy your assets on the Unity asset store and then use them in Unreal. But for me, like, I always just assume if I buy art anywhere, I can use it anywhere.
Yeah, there's no restriction on the EULA in that regard. So I do have a store on the Unreal Marketplace. So if you want things that are just already set up for Unreal, then go there. This is you can bring in the models yourself. A lot of the older models, their animations are just, attached to the FBX. So in Unity, you can create the different clips from that. In Unreal, it doesn't work like that. So importing them takes some time. You gotta just import it multiple times and import the animation only over and over and with the right frames. So it's a little bit of a challenge, but there's nothing stopping you from doing that. Getting it from Unreal, Unity, and using it Unreal. Though the ones on the Unreal are set up for Unreal though, and I'm between people right now, but there's a new person that I'm hoping to convince to help out manage the Unreal side of things. It's somebody who comes to this show, so he might be watching right now.
Nice.
And so definitely buy from there to support the Unreal aspect if you want it just to work right away. So, yeah.
And people seem to like that AI chat. I thought it was pretty useful too. So
it was a robust AI. Yeah,
it's a cool topic.
There was another super chat I wanted to pop up, but I don't have an answer to it. So I'm curious if you guys do, because I haven't looked at this open project Chop. And they asked if there's any chance we could talk about the scriptable object scene management pipeline used in that. Have you guys seen this one?
So I've not seen their specific. I know the project, and I've done and seen other scriptable object scene management pipelines before. I've not specifically opened or seen the one they're doing it here though.
Yeah, so I figured we could actually just show it to everyone first, because it's actually really under popular. Like it deserves to be shown. And specifically speaking, they have the entire system of the game running mostly on scriptable objects, based on that popular talk about using scriptable objects for events. I didn't look at it for a long while, so I'm trying to refresh my memory really quick, but there's a bunch of scene data scriptable objects that they author, and then they obviously can use it. It was a very...
I assume it's an asset with a series of additive scenes that are like bundled together, right, when it's loading different subsets?
Yeah, so So specifically speaking, if you go to asset script, scene management, and scene loader, they have a script there for the location loading and code loading and all that, based on game scene scriptable objects. And the game scene scriptable objects, they had something special there, I remember. Trying to figure out where the actual, yeah, there we go. Game scene scriptable object is specifically letting you say what type of scene you're actually loading, and then you have a scene reference to an addressable asset to actually load the scene, which you can do asynchronously and very easily these days. And you also have an audio cue for whatever the scene needs, which is also another scriptable object, which relates to an entire other system. So the entire thing is basically made for convenience of offering assets in an extendable way. When you're talking about using addressables and having scenes, it's a concept where you don't have to have everything loaded at once in Unity. You can load content as assets regardless of what it is, and it lets you have a lot more control on how you do the things when you're using addressables versus not. Sorry if I'm being a bit abstract. It's just that when you're loading scenes in Unity, it's way harder to load them in isolation and knowing when the load finished without actually activating it while having another scene loaded without using the addressable wrap-up, which has some special features. Yeah.
So yeah, this looks pretty handy though. I didn't realize that's how they were doing it. They're just using the asset reference. That way they can have a reference to the scene in there.
Yeah,
and it's worth noting. Sorry,
it also lets them update the addressables. Suppose the game shipped, and they wanted to update the game content. They could just update the addressable asset reference to say this level now loads another scene, or they could update the scene itself, the file only, regarding what this scene needs, swap it out, etc., etc. Because when you bundle assets or you try to make a big Unity build, it doesn't let you build everything cleanly, and addressables let you control tightly what you want to load in every bundle. There's a lot of benefits to that.
Yeah, so it's worth kind of thinking about this problem of how it stacks and what's happening. So we talked before about rendering being triangles all the way down. Well, it's the same kind of thing here, where if you're loading a game level, it's loading models and art and sounds. It's assets, ... assets as a concept. And there's lots of ways you could possibly figure out of how you might structure and store and load assets. Unity has the concept of scenes, and a scene is just, I have a hierarchy of objects. This thing has these children have these children. Some of them are models, some of them are sounds, some of them are scripts, whatever. And so if you want to load a level, you load a scene. The scene will load all the relevant parts to it, and off it goes and it plays. The good part about this is you've got a nice structured way to have different scenes and load different scenes. A possible downside to this, though, is if you load a scene into memory and you're like playing a level, if you die and you want to restart, you've got two ways to do this. You can either restart by like replacing the character back at the start position, but as you know, there might be a lot of things different. Like you might have collected blocks or picked up things. You might want to reset everything, and so you might want to reload the entire scene. And so if everything's in a scene, you're going to load the whole thing again. And even though 99.9% of it's exactly the same and is still there, the only bits that should really have changed is the character and a few bits of the interactable elements. You'd reload the whole thing, which looks slow, is time-consuming, and a bit frustrating. So what you can do is you can start to split that up even further and go, what if I have one scene, which is all the static stuff in the background, and I have one scene, which is all of the UI stuff that goes from scene to scene. Like I'm supposed to, no matter which level I'm in, it's still the same start menu, it's still the same pause menu or whatever. And then what if there's a whole load of stuff that's my interactable stuff, my player and the character and the boxes and stuff that I destroy? Maybe I have one for each area. Now, if you want to reload that, you just reload the bits that have changed, the interactable parts. And so all the background stays in memory and it's much faster to load and it works a bit cleaner. And so there's this concept of breaking down your project into these sub-scenes and then additively loading one on top of another to stack them together. This is also how you might do like level streaming, where you might have an area, and as you move across a boundary, like take an elevator into another map, rather than like loading out and loading in the new one, you might load the next one additively next door, tie them two together so the two doors line up, and then when you get far enough away, load out the old one, then try to like keep this consistent. You don't need to use Unity scenes to do this, but that's one possible way to do it. And it's worth noting that these kinds of solutions, they're all just solving the same problem, which is I have lots of stuff and I need to bring some of it in and some of it out at different times. And there's different fidelities to this. Some of it's based on an entire world, how much it should be in memory at one time. Some of it's based on how much can I see at one time. So if I've got 100 characters and they're doing backflips and running animations and things, some of them are in my field of view, some of them are outside. And if there's a character who's doing, if there's two characters fighting, two soldiers, and I'm watching them, I have to watch every part of it, the animations, the particles, the sounds, all the stuff. If there's two characters fighting behind me, the only part that needs to really be done is the part that I can hear and the number calculations for whether they're dying or not. All of the animations don't really need to be running right now because I can't see them. So there's a lot of like culling steps to this that basically boil down to when you're showing stuff on screen, it's incremental steps from how much do I load into memory, how much do I show on screen, how much processing do I do, how much processing happens in front of me versus stuff that's behind me. And so you can get really granular with this, and it can be a very complicated process for rendering. So long story short, the reason you do a scene loading system like this is there's a bunch of individual scenes that might be relevant to each other. So we're at the beach. The beach has the beach background and all the water and all that stuff. Then we might have the animated boats that come in and out of the harbor. That could be its whole other level. And then we have the collectible boxes, crates, coins, and stuff that are on the boats or whatever. These could be different levels, and you could load the layers in. And if you want to restart the level, you may only have to restart the collectible portion. And that's like a chunk that you can now load in and out in these different sets. And then once you move from the beach to the middle of town, rather than having this really jarring cut, you could have a long tunnel, and as the character walks through the tunnel, you secretly load out the old one and load in the new one, and it seems to organically flow from one to the next. So that's why all of this stuff exists, basically.
Yeah. And to answer the question about the scriptable object events quickly, so generally speaking, you have a scene, it's loaded, there is an event that needs to happen. And when that event is supposed to happen, what it goes and gets received on, you don't know. And when you're trying to load a lot of scenes, you'll find a problem where if the object isn't loaded, I can't tell it to register to this event. Or if this event is going to be triggered from another scene, how do I get my object that loaded entirely separately to be bound to listen to that event? And this is where binding the events to something that's not in a scene comes into play, which is why you have event scriptable objects. Scriptable objects don't live in any scene, they are assets. Therefore, you can bind events to them, call the events, and anything that's currently plugged into them will listen regardless of what scene it is in. So this is the advantage of using event scriptable objects. That said, they do have some certain caveats. For example, when you do that, everything is using the same source for the event. So if you have two players that are supposed to have entirely separate scriptable, entirely separate event calls, you can't use the same assets for it, or you have to supply an argument that says which player is making the request. It gets a bit complicated, but basically, you get the benefit of easy alphaing for your content regardless of scenes when you're using event scriptable objects. It's really simple. There's multiple big talks from Unity about it, fighting the tyranny of mono behaviors and using scriptable objects for behavior in 2017 talk. I forgot the name. The Firefly thing.
Yeah. There's quite a few of them out there. I've done a couple of videos. I think even Jason, didn't you make a video on those yet?
No,
I assume you will.
I probably will at some. I'm just trying to find out if there's something I can add to the discussion, because there's like the same. It's the fact that 2017 talk is just as valid now as it was then. Kind of highlights that. Yes, there's some stuff about addressables you could cover, but I'm sure other people could cover that better than me. There's nothing. I don't do anything special with them, so it might be. I'll give it some thought if I can find an angle that's unique. I will say
value, I think, in just re-explaining it. I feel like sometimes just hearing it a second time from another person kind of helps it click.
That's a fair point. It is worth noting as well, one thing on screen here on line 26, it's saying async operation handle, which is a very crazy sounding word and name, but it's worth noting as well that when you're loading things, the async sounds very fancy and it gets into a lot of complicated stuff, but in truth, all it really means is if you've got stuff in sequence, then imagine if you're doing you're cooking yourself dinner and you have to do each step one by one. So you cut the vegetables and then you cook them and then you put it in a plate and you do whatever. That's going to take a certain length of time. But if you have 2 people, one person could be doing one job, another person another job, and you can cut down on the end result, and the whole thing gets faster because 2 things are happening at the same time. That's all asynchronicity is.
Just to give a slightly cleaner example, if you are still a single person and you want to make an entire breakfast and you put a toast in the bread in the toaster and you expect toast, you don't have to wait until the toast is entirely crisp and ready and popped up to do other things. You can go and pour milk, you can go and make an omelet, and when the toast is ready, you will come and fetch it. This is what an async operation is. Basically, you don't
Exactly, yeah.
synchronously wait for it.
And that's kind of getting to why we needed this solution in the first place, is because you don't want to load scenes synchronously. You don't want the whole game to stop and say, hang on a second, we're about to load a whole other half of the map, everything stop for a second. You kind of want to be able to still move about and do things while things are kind of loading in the background. And so that's what asynchronicity is, and that's where the event problem comes into place. Because if you've got 2 or 3 things loading in parallel, and you have to wait till everything's finished loading and then line up the events so you can then do the next thing, that's what the problem is. So that's why we need to have some solution that handles the concept of events and loading kind of to the side, and then we can add it up and then attach the end result together, you know?
So I want to wrap this up by tying into something, because you talked about the loading, and one of the things that's on the flash deals was the
is it Sector?
Sector, yeah. So Sector,
Yeah.
I just kind of learned about it at GDC. They were
Sector's great.
Behavior design is also there.
Yeah, and it just lets you do that.
Oh yeah, there's
scene
behavior designer.
loading and unloading, right?
Yeah.
And behavior tree designer too. Looks like there's lots of stuff on sale. So
It's actually, funnily enough,
that out.
Sector ties into a lot of what we said, because Sector also has Sector audio, and Sector audio fires rays into the scene to do attenuation and scene audio, and gives you that spatial, like, sound changing depending on the rooms you're in and stuff, and occlusion. A lot of what we discussed is actually being used in Sector and the Sector suite in general.
I missed the link for it. It's in here somewhere, but yeah, you definitely should check that out. And if you're checking that out, also check out the conference this May, where the guys who made that will be speaking. I think we'll have somebody there talking, hopefully about something related, maybe even Sector. That could be an interesting talk. I'm going to see if that's a possibility, because I think that scene loading and unloading thing is actually it's a pretty big thing that I think that most people need to do and don't actually think about. And I didn't think about it as like an important topic talk, but I think that could be actually really interesting. So real quickly, if you're interested in that, just check out GameDevGuild.com. It's in May. It'd be a 3-day long conference. And also, if you're interested in that plus coursework stuff, go to game.courses. I got an Easter bundle where you can get a ticket to the conference and some courses all bundled up with a bunch of other cool free stuff. Also, with the Guild one, I didn't dive into it, but there's a bunch of cool free stuff that got added on, like Unity Pro licenses and other cool art and things that are more. There's a lot more coming, and there's a lot of stuff there. So definitely check that out. I also wanted to share Jason Story's coffee page right here. I'll drop that into the chat as well. Go donate and jump into the Discord and get into the interesting chats, and join his YouTube channel as well. I'm going through my copy paste of all the links right here. Go subscribe to Jason's YouTube and hit the little bell so you get the alert when the next video comes out and the next community post. Do you have a plan for the next one, by the way?
I have a couple of things that are kind of all partially done, but I'll admit this trip to PAX in a couple of days has been taking up a lot of my time recently with planning things, so I've been a bit distracted. But I have a few ideas. I don't know which I'm going to go with next, and I've learned my lesson about making a promise at the end of a video about what the next one will be, so no promises. I will make whichever one inspires me the most when the time comes. So.
Yeah, I found that sometimes I'll start recording a video and then realize it's just not the right video and it's not going to work. And then I'll have a random different idea that's 1,000 times better and just want to do that. So I did the same, like ask for people's opinion and then I'll make whatever I'm making afterwards.
But hey, if there is a particular topic you'd like to hear me talk about, if you put a comment in this video and ask, I'll read it. I read most of the comments, and I might put that higher up the list. Who knows?
That's where I get most of my ideas too, from comments. So and when I say that, like I do try to do the videos that people recommend and ask for, but a lot of the time, like I said, it just doesn't always work out. And then the last thing I wanted to share was the low poly bundle. So Andrew's got this on sale on the asset store right now. It's linked in chat. let's see. There we go. So you can go check that out. Go grab your low poly characters that will hopefully be in the battler next week. And get some time to put them in there and have them fight and fix up whatever other weird bugs have added into that thing. So any final words or last things you guys wanted to mention before we wrap it up?
So we had a lot to talk about today regarding Unreal Engine, but we still never got to get to the unsung heroes portion of it, where there was a lot in the changelog for 5.0 that we didn't get to. So I'd love to discuss that next week, if possible.
Yeah, I think that would be a great one. So if you're into Unreal stuff, we'll dive into that deeper next week. Go through how many things were there? It was a pretty big list, right?
Yeah, there were more than can fit on two hands.
Yeah, we'll have to go over that next week.
Yeah.
Cool. And then anything else? If not, I guess we'll just say goodbye and ask everybody to hit thumbs up. Anybody got anything?
Nope.
Right,
Just if you happen to be at PAX East, I'll be there. So there you go. So you can say hello to me.
I'll just fly out there and surprise you to show up. Be fun. All right. Well, thanks again, everybody, for coming out. Please like, subscribe, share the stream, and all that stuff. We'll see you next week. If you got questions, drop them down below. Go check out all of the links, the lightning sales, the conference, the other things that are all down there. And let us know what you think by hitting the thumbs up button because you love the show. All right. See y'all next week. Bye.